The sum product formula. It's one of the exotic ones. Essentially what it does is it multiplies matrices together and then adds them up, which sounds pretty complex, but as we'll see some pretty simple examples first, and then we'll see a more complex example to show a use case for it. So let's understand how the sum product works with this very simple example of arrays. So I have, this is my first array, and it's a 3 by 2 array, and this is another 3 by 2 array of 3 rows and 2 columns, and I can simply multiply them together with the sum product. So we'll say equals sum product, and we'll choose first array, and then I'll comma, and I'll choose my second array, and then I'll hit enter, and it gives me a value of 162. Now, how do we actually check if that's right and understand what's happening? Well, what happens is this: it says do the first one of this array, multiply it by the first one of this array, then do the second one of this one, multiply it by the second one of this one, and then just to speed things up a little bit here, I'll copy these down. But if I double click, it's the third and the third. If I double click here, it's the fourth and the fourth, and then again I'll copy, and it's that one there multiplied by that one there, and that one there multiplied by that one there, and then finally what it does is just as a sum of all of those added together to give me the 162. So it's multiplying all of the individual elements of this array against the individual elements in this array, their matching partner, if you like. So knowing that, let's go ahead and actually use it in an example. And this is perhaps the simplest example. I've been out shopping, I've bought these 4 things, and I've bought various quantities of them, and I want to get my grand total, which is just going to be the quantity times the cost, and then add it up. And obviously I could do that with just a quick helper column and a sum, but the sum product allows me to do it in one go, just with a single formula. So sum product, this is my first array, and this is my second array, and it just multiplies these individually and then adds them together. And just to double check, we'll just quickly do it manually as well for this first example. So $20, 45, etc. And then if I now pull those up with just a standard sum, you'll see it gives me the 226 as well. So the sum product does that in a single calculation, so it's nice and efficient. Okay, so let's say if you wanted to work out what the total would be once you've applied this discount to all of these items, then you might do it like this. We might say it's this multiplied by that, and we'll lock it to make sure that we get, so there's my $1, and let's just drag that down, and that gives me, these are all the discounts. Then we'll do that less the discount, so $9, drag that down, and then we'll do my sum here, and my total price, my total cost to me is going to be $135 after the discounts. Now what we can do with the sum product is do that all in one go. So we'll do in fact we could do this helper column, we could have made this quicker. Let's quickly see that first by saying we'll do this multiplied by 1 minus the discounts, and that just saves us having the 2 steps. It just applies, it just says tell me what 90% of the total is, so that will just get us there in 1 step quicker. But if we wanted to do that with the sum product, we can, and that again just does it in a single formula. So we'll say sum product, and we'll just do our array again, and then we'll multiply our array by the 1 minus the C2. We'll lock it, and what that does is just it applies that multiplication to each element in the array before it then sums them up, and that gives me straight away just my $135 in one formula, one single formula. Let's see another example. So in this example I have a list of products, years, regions, and then sales values, and what I'd like to do is know how many items product F we sold in the North region. I'm not worried about the year, so I've highlighted them to make this a little easier to see. So I want product F in the North region. Now obviously we could just do this with a sum ifs, and we'll highlight the range that we want to sum. We'll highlight the range we want to test. What's the test condition? Product F. We'll highlight the other test we want to do, which is column C, and the condition here is North, and hit enter, and there we go, 18,170. But we could also do it with a sum product. So let's build it up again in steps. So let's do, first of all, let's test for column A2 to A33, and let's do equal to product F. Enter, just gives me 1 true. So let's hit the array formula, enter, and it gives me the trues, falses whenever there's a product F, and false when there's not a product F. So let's do the same thing now with column C. So we'll do C2 to C33 equal to north, and we'll hit array, shift enter to do the array formula, and again we get the true falses. Then we'll multiply these two together, and you can see we get the ones and the zeros. So we get ones only on these highlighted rows where they're both true, so it's product F and north, it'll give me a 1, otherwise it's going to give me a 0. And then finally we'll multiply that by the sales amounts and drag that down, and then finally we can just sum that column there we've just created, and we get the 18,000. And what we've done is a manual sum product essentially there. So let's see that now with the sum product. So we'll do sum product, and we'll grab our first column here, and we'll say when that's equal to product F, and we'll grab our second column, our second array, and we'll say C2 to C33 is equal to north. And then finally we'll grab the third array that we're going to multiply, D2 to D33, close parentheses, hit enter, and there's my 18,000 by the sum product method. So again, it's sort of whatever you're used to and what you prefer working with. The sum product used to be the only way to do this sort of calculation. So before the sum ifs and sum if formulas, people were doing a lot more sum product formulas, but it's still good to know about how it works, because and understanding this kind of logic, because that will then explain, that will allow you to use this constructions, this type of work in your formulas. So let's see another example of the sum product where it does solve a specific case for us, and that's to look at some averages. So I have a little table here, some properties that belong in a portfolio, say for a real estate firm, for example, and it just tells me how many they have of each type, how many bedrooms there are, the square footage, and the rent per month. And we'd like to just calculate some sort of averages of the rent. So the most basic of all is just to say what's the mean. So what's the average rent in my portfolio? $2,027. But that doesn't really tell us the whole story, because I have a lot more of the family homes and the townhouses, which are higher rents than these apartments, which I don't have very many of. So really we should be calculating a weighted average based on the portfolio holdings, so how many we have. So what we need to do is multiply the rent per month by the number of items in the portfolio, and then divide the total by the total number of items, the total number of properties in the portfolio. And the nice way we can do that very quickly is with the sum product. So this is where it really comes into its own. I can start saying sum product. We'll multiply this array by this array. That's going to give me a huge answer, obviously, and then we need to divide that by the sum of all the items. So what's the total number of properties in my portfolio? And that now tells me that really your weighted average is actually $2,600, so just almost $2,600, and that's a more accurate representation of what this portfolio rental, average rental is. So now we might want to do an average of and a weighted average for each type of property I have. So I have apartments, I have townhouses, and I have single family homes, and maybe I'd like to segment that data. And obviously this first one is pretty easy. We'll do a quick average if. So we'll say average if, and the criteria is this here, and what I want the value here, the test, is going to be when it's equal to apartment, and then the average range, the values I'm going to average across, the ones I'm going to calculate the mean for, are these ones over here. And what it will do is just work out a mean for just the apartments. So it's 850, 1200, 1500, and the 1100. It'll just take those values only for this calculation, and it gives me 1162. Let me lock these ranges with F4 quickly, and so I can drag that down, and then it calculates now what the average is for each of these types of property. Now what I can do is again extend this weighted average idea and do a conditional weighted average here, and say, similar to this one, is do a weighted average within each of these property types. So let's take a look at that, and again we're going to use the sum product formula here, and much like we did up here with the weighted average, I'm going to be multiplying this column with this column, except this time I also want to have a third column that multiplies this one wherever it's equal to apartment. So let's do this in steps again. So we'll do this one, column equal to apartment, and I'll hit array formula. We get some trues and falses. What I'd like to do now is convert these into ones and zeros so I can do that multiplication of this column against this one and this one. And there's a little trick here that you may or may not have seen. It's not so common these days, but you'll see it in a lot of the old Excel forums if you hang out there or find out errors there. And if I just wrap my little calculation there with the parentheses, and then if I put in front of these parentheses a double dash, then what that does is coerce or turn those trues and falses into 0 and 1s. And that means that I can use that in my multiplication, and it just allows me to just identify these are the rows where the apartment is. So let's see that in action now. So we'll use this one as my first array. So we're going to do a sum product. And my first array is that one, which is all those ones and zeros. My second array is the number, and then my third array is the rent. And the sum product will then sum all of that up for me. So let me just delete that now. And obviously I need to then go ahead and divide. And what I need to do now is divide only the number of apartments. So I need to calculate the sum of the apartments. And we do that with our old friend, the sum if. And we'll sum whenever this again in A is equal to this property type here, and then the range that we're going to sum is this one here, which is the number of items in the portfolio. We'll close that parentheses, and then it gives me a $1,100 weighted average for the property. And obviously that's a little different, it's a little lower than this because when I look at my apartment types, I've got 2 at the 850 level, I've only got 1 at the 1500 level, which is a slightly more expensive level, and so that's going to pull that weighted average down a little bit. Let me go ahead and lock these ranges. I don't want to lock the G13 because I want that to move down each time, but I do want to lock these ranges that are in my table. Of course, you could have done that as well by using named ranges. That would be a neater, nicer way of doing that. And then let's take a look now. So the single family homes actually have been skewed upwards, been dragged upwards because I've obviously got some, if I look at my single family homes, then I've got 9 at the $3,600 mark, which means it's going to drag my average, pull my average up from 2,900, which is the plain standard mean, up to the 3,000, over the 3,000 mark. So that's the weighted average, conditional weighted average using a sum product there. So sum product's a nice little formula to learn, not that complex once you get used to it, and it's really useful. So thanks for watching, folks. So let's talk about array formulas. And if you really want to become an advanced Sheets user, then you're going to come across array formulas, and it's worth understanding them and knowing how to use them, because there are certain things you just cannot do without them. Now, there are two ways of doing array formulas in Sheets. One is with the curly braces or the curly brackets, and we'll look at that first. And then the second is what we call the Control Shift or the Command Shift Enter formula, and that puts in the word array formula. And essentially what that means is the formula is going to perform multiple calculations on the items in an array that you give it, and either come back with an output, which will be a multiple set of items, or a single output, but it can work with more than just a single cell when it's performing these operations. So let me just show you some very quick examples of this curly brace notation, as I like to call it, curly bracket notation. And this is how we can bring data together to make other bits of data that might be useful in our calculations. So here I have a sheet, and I have a few rows over here in this blue array, and then I have some more rows here in this pink array of the ABC. And what I'd like to do is bring them together in into a horizontally, and then bring them together vertically. And why we do this is because when you start to get into really advanced formulas, you need to manipulate your data and be able to move it around at will, so that you can perform calculations on the bits of data that you want to perform calculations on. So for example, you might artificially create an order column like this, attach it to another array like this, do some mathematics which affects the order, but then you go back and you resort by this column which you originally had, and then you drop it again at the end, and you can do all of that live inside of your formula, so that you never even see this row, if you like. So there's lots of cool funky stuff you can do with array formulas when you get the hang of them. But let me show you the fundamentals of how we combine data. So we'll start with the curly bracket, and that's this one here. We'll highlight this, and we'll do a comma, and then we'll highlight this. Then we'll close the curly bracket and hit enter, and you see what happens is it joins those two, it brings those together into a single array now that we can go ahead and use. And now we can combine them vertically as well. So if we highlight this, use the semicolon this time, and then we highlight this one, and then we close the parentheses, and we hit enter, you see that it's brought them together vertically now. So that might be super useful if you've got multiple columns of numbers and you want to perform some math operations on them, some averages, some sums, whatever. You could combine them all very quickly with this bracket notation into a single column, and then go ahead and actually do that work. So always keep these fundamental, the comma and the semicolon in mind, these two fundamentals. So the comma puts the data side by side, the semicolon stacks the data on top of each other. Now let's see a quick example of when this might be useful, and that is when you're doing your VLOOKUPs. You might need to just rearrange the data before you could go ahead and actually do the VLOOKUP. I mean, I'd advocate learning the index match, and this is a moot point, but let's just see this for completeness anyway. So what we'll do is we will take this one first, comma, and then we'll take this one, then we'll close that curly bracket, and what it's done is it rearranged that data now. So if we were doing a lookup, for example, and we want to find out the rent due from Mr. Liam Peterson, and if we try to do the VLOOKUP in the original table, then obviously, oops, I missed off. We're going to search for H4. So we're going to search for H4 in that little table. Obviously it's going to give us an error because it doesn't find Liam Peterson in this one here. But what I can do is if I go ahead and just copy this array formula that we did where we swapped the columns round, and I just put that in there instead of that original range, what it does is swap those round. Then it does that, it calculates that for us on the fly, and it swaps those round inside of the VLOOKUP, so we can then go ahead and perform that operation and do that lookup and find Liam Peterson, and then move across to the second column, and it can do that inside the VLOOKUP. So that's a quick application just to show you how that works. Now let's go and see the actual Command Shift Enter version, or the Control Shift Enter functions. And this is one that we looked at. If you've seen the SUMPRODUCT video, then this is one you can do very quickly and easily with a SUMPRODUCT. But we can also do it with an array formula, and we can simply say, is this one multiplied by this one? Now if I hit enter now, all it does is just just do the first one of those two, because it just, the standard formula just takes the single first item and the single first item from there and multiplies them. If, however, I click back into my formula bar here, so I highlight the formula, make it active, and I hold down Shift and I hold down Command or Control if you're on a PC, Command if you're on a Mac, Control on a PC, and then hit Enter, then you see it puts that word array formula around there. You can also just type that in if that's easier. Then I hit Enter, and this time what it's done is actually multiply each element, all of the elements in turn, and put the outputs here for me to see. And then what I could do finally is just put a sum around that. Now it doesn't really matter whether I put the sum inside, which is what I tend to do, because that's the way the array formula would calculate if you did it. If you do it this way, and you first of all just, and this is the way you would do it, you first of all do your formula inside of the sum, and then you hit the array formula, then it puts that around the very outside. But you could equally have done this one multiplied by this one, hit the array formula, and then wrap it with the sum at the very end, and it's still valid. To me, I like to have that array formula kind of at the outside of my formula if possible, so that I can just see in a glance that it's an array formula. Because if it's buried deep inside somewhere, then there's a chance I'll miss that, and maybe that will then make it harder for me to understand how the formula is working. But it doesn't matter which order, just the fact that you've got array formula in there will tell Google Sheets that this is an array formula that you're working on. So that's the equivalent to a sum product with the array formula. Let's now take a look at how we might use the bracket notation to do something cool with our query function. So let's say we just want to do a quick query here, summarize this table of data here, which is these departments and how many positions they have open, or rather how many positions I have working there in each of these. I want to sum them together, because you can see, for example, I have, for whatever reason, I have a few things listed on the list many times. There's lots of duplicates there. So let's do a quick query and aggregate all that data. So we'll highlight the data. We will open and we'll say select A, which is the agency, the sum of B, so that's going to give us a total of the number of positions. We'll group by A, and we'll order by B, sum of B, sorry, DESC. Now if that doesn't make any sense, I'd suggest going and watching the query function videos, which are part of this course, and that'll help you understand what I've just written there. But if you want to continue with this lesson to see the array formula part, you can just copy this directly into your sheets and we'll go from there. Now what this does is it gives me now that data with a nice total of the positions, of how many positions there were for within each category, rather than them broken out like this. And what I'd like to do finally is now actually just go ahead and, well, first we'll do the calculation down here. We'll have the word total, and then we'll have the word sum, and what we'll do is we'll sum this original column over here, which gives me 203, which is the same as the 203 there. Okay, so let's see how we construct this with an array first. So we'll do the open bracket notation, and then our first item in an array is just going to be the word total. Then we'll do a comma because we want these to be side by side on the same row, and we'll say sum, and we will start with B here all the way to the bottom, close that parentheses, and then we'll close the curly brackets, hit enter, and what that does is give us exactly the same result as that one we had here. This time though, it's just a single formula that's here on my in my array formula. And now the last step is just to add this total now into my query here. So let's go ahead and see how that's done. So let me move these down out of the way so that we're not confusing ourselves, and we'll go ahead and just put a curly brace in front of my query, and then I'm going to put the semicolon, and that means now that I have that as my first chunk of data, if you like. I'm going to add a second chunk of data, and we'll open the curly brackets again, and we're going to say total, and then just to make things, just to understand how we're doing this, we'll put TBC rather than put the formula in yet, just to keep things simple. We'll close that curly brace, and what that's doing is constructing a new row that has, it's one row by two columns, and that matches then, this is 2 columns wide, this data up here, and then I'll close that parentheses, that curly bracket, and that adds that row to the bottom there, you'll see. And so what I can do now is change that TBC, which the formula is up here, is change that TBC to the sum of B4 to B53, and that will change that from it'll change that to 203. So let me clear these out, and then one last thing I might actually do is just to remove the 53 references so that we keep in fact we'll change that to a 3 so it matches. And the way, now what that means is that we've added, what I've done is added in the entire columns, and so there's now a value of null in my data set. So it's found that null there, and that's why I've got suddenly this blank line here. I can get rid of that, and you'll see this in the query lesson by just quickly applying a where, and that will bring that back up. Now the reason we do this, why I would want to do this potentially, is let me just add on a new department here, new department, and we'll make it quite different. So we'll see, and we'll say there are 999 people in this one, and let's go see if that's been added into, there it is, it's just automatically added into our query, and I have my totals being updated to reflect that as well. So that one's a really nice use of an array formula to make sure you have a total on your query function. Let's see another example. So I have a sheet here of form responses. So let me just show you the form before we, so it's a very simple form, and I just select a number between 1 and 100, so it's not too difficult. So I'll click 55, and that should show up in my spreadsheet. There we go. So let's see how we might use the array formulas here to create some totals, averages, and ifs, and I'll show you what I'm intending there. And the reason I might use an array formula here is because if I have a standard formula, then I'm going to have to drag that down every time I get new responses. If I have an array formula, I can set it up in such a way that anytime a new row arrives, it automatically just fills the calculation in for me. So let's just take a look at how that works. So I'm going to use the if formula, and I'll say A2 to A not equal to blank. So when it's not blank, A2 to A, then put in the sum of B2 to B, and if it is blank, put in the just nothing, a blank. Now if I hit enter, then it gives me 402, big deal, it doesn't go anywhere. But if I hit command shift enter, shift command enter, or shift control enter, and I put the array formula around it, then it will fill in that 402 all the way down the column for me. So that's pretty nice. Now I can copy that formula, and we'll put it in here, except this time we'll actually change it to an average, and what that will do is calculate a running average as new numbers get entered. So let me just show you that before we go too much further. So let's add another one that is number 1 and submit, and you will see in a moment that what it'll do is add that to the formula there, and it just goes up to 403, and the average now to 44.7. If I add another one, and we'll choose 100 this time, then we should see this jump up to 503, and the average jump up as well. And there we go, it jumps up to 503, and then the average now is 50.3. So I could do even an if statement type calculation here, and again, we always start with the if A2 to A is not blank, because then that allows me, every time a new entry gets added, that will then perform the calculation for me, because that cell is no longer blank. So if that's the case, it's not blank, then if the value in B2 to B is greater than the value in D2 to D, so if is it bigger or smaller than the average, then it's going to be above average, otherwise it's going to be below average. We'll close that, and then we have the final one, which will be just the two blanks. If there's nothing in column A, we'll close that one, we'll array formula it, and it'll tell me now that these ones, so 7 is below average, 45 is below average, 92 is above average, 25 is below average. And if I add another one, and the average at the moment is 50, so if I add something that's 45, I know that's going to be below average, but also what will happen is that average is going to move down. So if I keep submitting 45, then that average is going to drop over time. So that's using an array formula, and you can see it just fills in automatically every time. So that's a really nice use case for an array formula, to just set that up. So when you have form submissions, you can do those calculations on the fly automatically without having to drag these down. So that's array formulas, folks. Thanks for watching. Welcome to this lesson about the import range formula. The import range is a function that we can use to bring in a range of cells, a range of data from different spreadsheets, so from different Google Sheets into this one. So we're going to see a very simple example of how we use it with just to import one range of data. A second example, how we bring together several different sheets into one table. So let's take a look. Now in Excel, it used to be really easy. You could just go ahead and click on the other one. And because they were both files based on your desktop, Excel would just create that link, that file path, and be able to just transfer that data across. So to illustrate what I mean here, I've set up some additional sheets, some separate Google Sheets that have some data in that I want to bring together. So I've imagined that I have 3 classrooms that I manage, and each one has a set of results and some test scores. And so what I'd like to do is actually centralize all of that in my single sheet so that I can compare those classes. And rather than copying and pasting data, we can't just click through to these either. So what I need to do is actually use the import range sheet to bring that data in. So the first example we're going to look at is just a very simple one to bring the data from class 1 into this sheet. We do that using the formula import range. And then it tells me, if you look, that the first argument is a spreadsheet URL. Now this can be hard-coded as a string like this, a text string, which is what we're going to do here. Or you can reference a cell where that URL could be. So if I copied the URL into one of these cells, I could just reference that. But what we'll do is actually, we will go ahead and we'll just go copy it. So I just highlight the whole URL for class 1 there, Command C, come back to my sheet I want the new data in, and I paste that whole URL, put the quotation marks around it, hit comma, and go back to class 1 and then say what range is it that I want to do. And I want to do sheet 1 from A1 to E18. So again, we'll just type that in, sheet 1, A1, E18. And then again, put quotation marks around that, close the parentheses and hit enter. And it will give you an error message the very first time. It will give you these ref messages. And what you do is you click back on that cell with the reference error, and you get this little box here that says you need to connect these sheets, and a big blue button that says allow access. So you click that, and lo and behold, what it does is brings back that data from class 1, from that sheet 1 that you specified, from A1 all the way down to E18 there. And that is it. So it's really not a very difficult formula. But what we'll do is we'll see how we bring now, we'll look at another example now of how we bring together class 1, 2, and 3 into a sheet. Okay, let's take a look at the second example now, which is a little more complex. And what I'd like to do is bring together the data from these 3 sheets here. So class 1, class 2, and class 3. And what you notice is that they all have the same columns. And that's important for this technique because I'm going to be stacking these data sets on top of each other. So I want those columns to all line up. And you'll also notice that they don't necessarily have the same number of rows. So this one had 15, this one had 20. And that's okay, because what will happen is that we're going to stack them all on top of each other to make one big single table. And so we'll use the import range formula again, and let's go and see that in action now. So what I'll do is I'll be using this curly bracket notation, which I explain in some detail in the array formula lesson. So if it's new to you, I'd suggest you go and check that out first. But essentially what it's going to do is create an array for me that allows me to stack these tables on top of each other. And then within here now I can just specify my import range formulas and build the table that way. So we'll do import range, open quotations, we'll copy the first one, and comma, and it's sheet 1, A1 to E. And notice this time I'm not going to specify an end row, because the rows, they have varying number of rows and maybe there'll be new data being added. So if I just leave that row number off here and just stick with E, then that gives me the flexibility that it will just take everything in A1 to E, everything in those columns as far down as it needs to go. So I'll close that quotation, I'll close that bracket, and then it's very important now I've put the semicolon, and what that does is it is going to stack the data vertically on top of each other. If I had a comma there, it would try and stack the data side by side. So then I'll start the second import range formula, and this time I'll take the second one. So I'll just highlight that URL, paste, close quotations, sheet 1, and the nice thing is the way these are set up is it's exactly the same range as for that first one. So it's just going to be going to sheet 1 of class 2 this time, and again from A1 through to E, as many rows down as it needs, all the way to the bottom. And then I close that curly bracket there, and we should be good. Except what will happen is we'll get an error, and I want you just to think about for a moment why that might be. The very first time we try it, and it's going to tell me a value error, and it's saying it was missing values for one or more rows. And if you recall, with the very first time in example 1 with the import range, we had to authorize that spreadsheet. So we've authorized it to bring the data from class 1. What we did not do is authorize it to bring the data from class 2 yet. So we need to still do that. So let's just copy that second import range, which is our class 2 one. I'll hit escape to come out of that formula. I'll come over to the side here. I'll type in equals and I'll paste that in. Just get rid of that there. And this time what I'll do is I'll hit enter for just the single class 2 sheet. And you see it just asks me to allow access. And when I do this, this formula over here will pop back to life as well. So before you build these very complex formulas with lots of import ranges in, you need to just go ahead and quickly authorize them all first, and then you can go ahead and build your sheet. So we'll click allow, and that should bring that back, and it brings this one back as well. So that's good. So what we'll do is we'll go ahead and just delete that one now. We've authorized it. And you look at this now and you think, well, hang on, it's only brought class 1 back. Where is class 2? But if I actually scroll all the way down, let's see, far enough down. So this is all the rows from class 1, and there's class 2. Starts at row 1001. And the reason it does that is because I said bring in all of the rows from class 1. And so if I look to the very bottom of class 1, you'll notice that it goes down to row 1000. So it brings those 1000 rows back, even though 990 of them are blank, and then it puts in class 2. So what we'll do now is actually just wrap this. It's very easy. We'll wrap this in a quick sort. So we'll say sort. There's our data set, and we'll sort by column 2, and it's going to be true. And there we go. It should then bring up class 1 and class 2 together. So all I did was just resort the data, and it moves all of those empty rows down to the bottom. So that's really nice. One thing it's done is you'll notice it's brought a heading row from each. And so that's a very easy fix. What I'll do is I'll just change the A1 to an A2 there for the second data set, hit enter, and then it always just takes a moment. It sometimes gives you it gives you that little error message when it just takes a moment to bring the data in. But that's now brought that data together. And you'll notice if I add, let's say I add a new student to class 1, new student class 1, and they get 99, 99, and 99. Then we go back to our import range, and we'll see that there's our new student automatically has been sucked through into this new data set. So we could go ahead and add the third one very easily as well. First of all, if you remember, what we need to do is just quickly give it permission. So let's do that before we actually go ahead and try and add it into our main one. So we want then sheet 1, A1, A2 in fact, because we're going to miss the header row this time as well. We'll click enter, it'll give us the ref. We'll say allow access. There's our data for sheet 3, for class 3 rather. Copy that, hit escape. We'll just delete that one now. Come back to my main formula, and where I had at the end of the import range for class 2, but before that curly bracket I'll put another semicolon, and then I will paste that data, and that's my sheet, my class 3 now brought in. We'll hit enter, take a moment, and now it should have all of class 1, class 2 and class 3 together. And so that's a really nice way of bringing those 3 together. Okay, so that is the import range. It's how we bring data across from one sheet to another. And thanks for watching, folks. Hi, let's talk about the import formulas that Google Sheets has. And these are some pretty special formulas. And what they can do is go and do some basic web scraping for you, grab data from other websites and just bring it straight into Google Sheets for you. They can get hold of social media data, that kind of stuff. So let's take a look at some examples here. I'm going to show you 4 examples to illustrate these formulas in action, and then I think you'll understand how they're working. So the first one is a list of the highest mountains on Earth. It's a topic of particular interest to me because I'm a mountaineer, or used to be a mountaineer. It's been a few years now, but I do love my mountains. And here's a nice table here of all of the data for the highest mountains in the world. So the top 108 highest mountains in the world. So let's take a look at how we might import that data. Rather than copying and pasting this into our Google Sheets, let's use a formula to do it for us. So we'll do import HTML. We'll open these parentheses, and let me just click open it out. And you'll see the structure of the import HTML is it takes a URL, so the web address, and then it can import either a list or a table. So the next word along is either list or table. You put that in, and then the index, which identifies the table list as defined in the HTML source. And all that means is just the order on the page that that list comes in. So let's just take a look. So we'll copy that. We'll put that into our formula, close those quotations, and we'll do table with this one. So we're looking for that table, if you remember. And let's just start with 1 and see what happens. And so the first table was just this bizarre empty square, and then this one square that says something about the article containing original research, not what we're looking for. So let's just see what the second table is. And again, this one's a little bit of a funny one. It's just some data. Well, all that means is it's data somewhere on this page that is arranged in tabular format. So it could, for example, these might be tables here, all this kind of stuff. There are lots of different tables hidden inside these HTML documents. And what we'd like to do then is keep trying until we find the table that we want. Now, it's a little bit of trial and error at first, but you'll get the hang of it. And there we go. There's the table we want was table number 3. And it's now got all of that data from that table in the Wikipedia article, and it's now sitting pretty in my Google Sheet. And if I now want to work with this data, then it's a good idea to convert this back to actual values in my sheet rather than leave it as this live link. I need to highlight the whole thing first, then copy, and then paste special and paste values. And then what that does now is actually just change all of that to values in my Google Sheets so that I can actually, do the necessary analysis that I want to do with it. So that's the first example. That was using the import HTML formula with the table. And let's go and have a look at an example using the list variant. And let me now show you this article online on Huffington Post. And this is something you might find yourself doing frequently if you're doing research. You might come across here and say, okay, I'd like to get a list. I want to get all of these Twitter handles into my Google Sheet. In this format here, they're not particularly useful, and it's kind of time consuming to highlight each one like this and copy and paste them. So let's see how we would do that with a formula. So again, we'll start with equals import HTML, and this time it's the Huffington Post URL that we want. So we'll put that in. We'll close, and this time it's a list. So we said last time it was a table, it's a list. We'll do the same method as before. We'll start with 1, then we'll try 2, then we'll try 3 until we find the one we want. So the first one, number 1, the first list was just somewhere, this here is the first list, it's 3.8K. So, that might be a data point you're after, but not the one we want in this case. Let's see what 2 is. This time it's the exact one we want. And if you a bunch of Twitter lists and then some more Twitter lists. And if I then change this to a 4, it gets me the next list. If I change it to a 5, it gets me that next list. So you could quite easily scrape all of that data and bring it in. There we go. And you can even actually reference you could move this Twitter reference here, or this list reference, sorry, into a separate cell. So just that cell C1 there I'm referencing. And it's just taking a little while to load that data up. But now if I change this to 4, it will reload that data. You've got them in this format. If you want to quickly pull out the actual Twitter handle there, then it's pretty easy. We can use a formula called mid. We're going to search for this one. What we're going to do is actually search for that hyphen there in the middle. That sort of denotes where the Twitter handle starts. We'll search for that inside of here. We'll start from position 1. Then I need to add 2 because when I find it, that's position 1. I need to add that on. I need to add the space, and then I need to start extracting that data. And the length that I want to extract is we just give ourselves plenty of extra room at the end there because I don't know how long these strings are. So I'll just, if I put 1,000 in, it's always going to find all the cells, all the string at the end there. So that gives me all things D, and that gives me all the way down to the bottom there. Now if I don't want the @ symbol, I could just increase the position I start from, so I can move myself 1 further along, and I start extracting from the A this time instead. Copy that down, and there they are. There's all those Twitter handles, very quickly extracted those. So okay, let's see another example using the import formulas. And what I'm going to do is go to this Business Insider article. And let's say you're doing some analysis and you want to extract things like these bylines. So let's go and take a look at how we get the byline into our Google Sheet using the import XML formulas. So of course, the formula we'll use will be import, and there it is, XML. We click the URL we want. And then we need to give it the XPath query in between the quotes. So let's go and find the XPath query for the byline, the author's byline. So we'll come into here, we'll come to File, View, Developer, Inspect Elements. And what this does is it opens up the Developer Toolkit, and it lets you go and inspect the code behind the website. So I'll hover over the name there, and you can see it tells me down in here all about the piece of code that generates that name. So we have, for example, this div. This is the one we want. This div, it's a division, and this is an HTML tag, and it has a class byline author. That sounds like the thing we need. So let's pull out the div with the class byline author, and it should then return that name, the name contained within inside this div. So that div there, if I open and close, that div is the div that contains the name. So if I double click there, it just highlights that. I'll copy that. And the first thing we need to do is get a, go to the div. So we'll go div like that. And then we want to go inside the div and find the one that has a class equal to copy the byline author. So let me just close that. So what I do is I find the div, go inside the div, that's the square brackets, find the div that has the class equal to byline author. We'll close that off and then hit enter. And that should bring back that name. There we go. So let's go and find the timestamp as well. So that's just right next to it here. Div class byline timestamp. Now it's interesting, when I try it with the byline timestamp, in this particular example, it doesn't actually pull out the dates. So instead what I decided to do was use this data timestamp here, which is equal then to that value, which is the actual value of the of when the post was posted, because otherwise I'd be pulling back the 3 hours anyway. So if I use this data timestamp, that's inside the div. So what we'll do is we'll come back here and we'll say import XML, this article, open quotations, div, oops, // div, open the square brackets, and then that's the item within the div that I want to bring back, the actual value of that. So I'm not setting the value equal to anything, I just want to return that value. Hit enter, and there we go, it brings back that piece of data for me. Now XPath is a complex, cumbersome, challenging syntax. So let me show you a resource that's quite handy in getting the basics dialed. So the approach is always to find whatever you want on the web page, assuming it's not behind a login, because obviously these formulas don't work through logins. But assuming it's on a public page like this, go and check out the inspector element. So inspect the element in the developer console and see if you can use the information there to create an XPath query that you can put into that query formula, that import formula. They don't always tie up. Sometimes it doesn't work when the website is built differently than what the XPath query needs to be. So here's a nice website, w3schools.com, and it has an XML example with some how you go ahead and select the different nodes. There was the double that we used and the @ that we used to get the attributes of a particular node, and it gives you some details and examples. So I would say go and check that out. It's a very handy guide to do these XPath things. And then one final example I want to show you is one of my social media, one of my beloved social media extraction methods. And as I said, there's a whole range, a whole set of formulas to do the social media statistics as best I can, because not all of them work. And that's listed on my website with the link below. So we'll take a look at extracting the Instagram data. So I'm going to show you my Instagram page. A lovely photo of me and my brother there. And there we are again. And lots of sunset photos, lots of running photos. So kind of boring unless you're me. But what I'm interested in is these topics, this data here. So how many posts, how many followers, and how many people I follow. So again, what we'll do is we'll copy the URL up here into part 1, and I'll go ahead and use an import formula again. So we'll say import XML again. There's our URL, and this time the XPath this time is the meta, which is the metadata for the page. So that's the data that you don't see necessarily, but it's associated with the page, and it describes the page and tells us about the page. And the name that we're after, this is the identifier this time, is description. So we're looking in the metadata where it says description, and then I want to close that. And then what I'm interested in is from that description is I want to extract the content of that description. Let's see if I've got that Right, and there we go, it extracts that for me. So I had 140 followers, 309 following, and 306 posts. So if I now change this to a brand, let's try Nike. So there we go, there's the data for Nike. So you can't do any calculations yet with these follower numbers or these following numbers. And maybe you'd like to work out the ratio of following to followers and see if there's any sort of trend there. So what we'd need to do is actually convert these numbers, extract these numbers and convert them back to numbers. And that is pretty tricky to do. So I'm not going to go through the teaching that whole thing. I'll just show you the example here we use. And what this does is, again, it imports exactly, if you look there, there's the import formula I just showed you. So it pulls out that string of data, and then it searches for the followers first using this regex, which is another lesson we're going to look at. So go and check that regex out. But what it does is goes and finds any data associated with followers. So all of this is just to extract this followers number. If you want to do following, you would change it to following. So it extracts the followers, and then if it finds a K, which would mean 1,000, it replaces it with 000, or times it, multiplies it by 1,000 rather. If it finds a M, which it does in this case, which is a 74.8 million followers, so we don't know the actual exact precise number, but we know it's 74.8 million. We're going to times this, we're going to extract 74.8 and then multiply that by a million to get our number. And if it doesn't have K or M, so I'll show you again what my one looked like when I had only 306, then it just extracts the plain number. So we'll hit enter, and what that does is extract, if I just change that to a number, go to decimal places, extracts a 74.8 million for me is 74,800,000, and I could just go ahead and actually do work out some calculations with that. Now quickly, just to show you, if I change this back to mine, oops, I missed off the S there, that's why. Then you'll see it just extracts the measly 140 followers that I have on Instagram. So that's using the import XML function to extract the data from your social media accounts. There's a much more complex formula to then go ahead and parse that. As I keep saying, I've posted the link below to where these formulas are explained on my website. Okay, so that's a whiz around most of the big import formulas in the Google Sheet. There are a couple of others, import data and import feed, which you may find useful for certain specialist applications, so check them out in the Google Docs. Links are below. But otherwise, that's a look at the really wonderful world of the import formulas. They're really fun. Thanks for watching, folks. Yikes, it's the regular expression lesson, and if you're full of dread, then imagine how I'm feeling trying to teach this to you. So what I'm going to do is actually not try and teach you regular expression, because that would be a course in its own right. So in this short video, what I'm going to do is just explain it a little bit, point you to the resources you need, show you a whole bunch of examples of some common ones, and hopefully that will be enough to get you started and give you some useful regular expression functions to use. So regular expression is it's essentially a sequence of characters that we specify that we then use to search for pattern matching, and so it searches through strings for this pattern that we've given it, and if it matches it, then it can act on it. It can give us, it can return as a true or false to say it found it, which is the regex match. It can extract the bit of data that we want it to, which is the regex extract, or it can replace the data that it finds with some other data we specify, which is the regex replace. So there are three regex formulas: regex match, which is sort of do you find it, yes, no; regex extract, which is to pull that data out; and then regex replace, which is to replace the data with something new. And we'll look at examples for all three. So we'll start with the very first one, which is the regex match. And what I do is I've got a very simple string here, just the word alpha, lowercase, nothing crazy going on. So we'll say regex match. And if you look at the formula, then what it wants is the text first as the first argument, and then the second argument is what's the regular expression I'm trying to find. So the text in this case is A1, and what I want to do is say, hey, do you find any lowercase characters in this spreadsheet? And let me just explain what this gobbledygook symbols mean. So the first one, the upper hat, just means I'm starting. This is at the start of my, you're going to find this at the start of my regular expression. And similarly, the dollar just means, hey, this is going to be at the end of my regular expression. And so the whole regular expression in this case is going to consist of lowercase letters from A to Z. And the star just means you're going to find 0 or more of them. So essentially what I'm saying is that I want my entire word, my entire string, to only consist of lowercase letters of A through to Z. So only lowercase, it can be 0 or more of them, but they must start at the very beginning of my string and end at the very end of my string. And that's what I want to show. So let me hit enter, and let's just now see what happens if I say put a capital alpha. Then it gives me false because it no longer finds that all of the letters in my string here are lowercase. Now if I had the, let me just copy this, put this underneath, and if I didn't have the hat or the dollar sign, then it would work again, because it would say, do you find any lowercase letters in my string? And in fact, the way I've written it with that star means that even if it was all uppercase, it would still be true because it says 0 to more. So in fact, this one's always going to be true. So this one's always going to be true. Now, what would be interesting is if I change that star to a plus, then what I'm saying, that the star means 0 or more. So anytime there's 0 or more of the lowercase letters, and the plus means it must find at least one of them. So now it fails because there isn't a lowercase letter anymore. If I put a lowercase letter back in, it becomes true again. And this one's now false because it's saying that, it's still false rather, because it's saying everything from the very start of my string to the very end of my string, which is the hat and the dollar sign, must be lowercase letters, and the star is just saying there's 0 or more of them. So how would we adjust for that? So this one, let's delete that one now. So this becomes a true statement if we want to adjust. Well, what we can do is we can adjust the in here and say, look, it can be the lowercase letters or it can be the uppercase letters. So from A to Z, or uppercase A to Z, A to Z. So that's great, that now works. What if I had a number in there? It fails again because I haven't included numbers in my test. So what if we actually go ahead and try and add the numbers in? Well, we say, we're just doing exactly the same thing. Look, it's 0 or more lowercase, it's 0 or more uppercase, and it then has 0 or more of the numbers as well somewhere in that expression. And that's now true. So if we go back to make it a little more readable, let's do alpha 100, then that works. Now if we put a space in here, then it's going to fail again because we haven't matched a space. We've said that from the very first character to the very last character of my string, it must only consist of lowercase, uppercase, or numbers. So lowercase letters, uppercase letters, or numbers. There's no matching for a space in my text there. But if I just simply come inside of my brackets, my square bracket, and put that space in, then that now adds that to the mix. So I say it can be any lowercase letters, any uppercase letters, any numbers, and then finally even any spaces, and the star means 0 or more of them. So I could have multiple spaces in there and it would be still true. So what if I then have a comma or some other digit? Again, I haven't specified that, so the regex becomes false. We need to tell the regex that that might occur. And again, all we simply do is just add a comma to our pattern matching. We say that that might turn up and it becomes true. Let's keep going. Let's try adding, say, some parentheses. And we want to try and match those. Then what we need to do is just add in those parentheses. And what we're saying is my pattern can have any of these. So it can be the lowercase, the uppercase, the numbers, the space, the comma, or the parentheses. And that must stretch from the beginning to the end of my string. So I'll hit enter and that gives me true again. Okay, so that's a very quick rundown of the regex match there, just showing you a few concepts of how this system works. It takes a long time to learn regex. I've been using it for probably on and off for a couple of years, and I still find myself having to figure things out and work stuff out, and you know, I'm still learning lots of new things. So don't be surprised if it really feels very, very difficult to start with. It does, and it will take a little bit of time. Let me show you a few more concrete examples though, and things that you can go ahead and just use off the bat without needing to figure the formula out. So let's take a look at regextract, and let's see how we would go about extracting an email address from this string, because this is kind of an interesting example. You might download some data, you might scrape some data off the websites, off the web with the import formulas, and you have a string like this which has the email address sort of buried in the middle, and it would be really nice rather than having to manually copy and paste these out if we had a formula that could extract that email address, and it's really not too hard. So let's go ahead and take a look. So this time we'll use the regextract. So this time we'll use the regextract formula. The text is this one here, and what we're going to do is we're going to search for some string before the @ symbol. We're going to find an @ symbol, and we're going to search for some string after an @ symbol with a period, and it must have a period and it must have something after the period, and there's a space before and a space after, and that will be sort of our limit. So we'll look for anything that has a space beforehand, an @ symbol in the middle, a dot, a period there at the end, and another space to follow. So it's really, when you sort of break it down like that, it's not too difficult. So let's do, it could be the lowercase A to Z, it could be the uppercase A to Z, it could have numbers, it could even have underscores. Now it could have periods, but the period is a funny one, so we need to actually use the / period, because the period itself actually means something in regex. So it's important that we put that / in to denote that we're searching for the period. Similarly, the plus there, plus is a symbol used by the regex, so if we just have plus without the / then it thinks it's meaning something, whereas what we want to do is actually search for a plus sign, because that can be inside of your emails, and then we could also just have a dash there at the end. So that would capture all of the different types of text that we would find. And if I now close the parentheses, and I then say it could have a plus, which means one or more, and you can see already it's finding the word let. So it starts at the beginning of my string and it finds let immediately, which was the first word of the string. But what we'll do is we'll put that @ symbol in, and what it does now is, if I just close this, so we can just explore this a little bit more. It's going through this string of mine, and it's saying search through this string. So in fact, what we'll do is we'll just actually even widen that out so you can really see. So it's saying search through this whole string here, and I want you to find a word with one or more characters. So that's what that little plus there means. Then these are the characters that can occur in the word. So it can be any lowercase letters, any uppercase letters, any numbers, an underscore, a period, and we use that / to say it was a period, not the regex expression period. We use a / with the plus to say that I'm searching for a plus, not the regular expression plus, and then it dashes as well. So any word that's made up of that and that comes before the @ symbol, then extract that for me. So if I had Ben, and this is quite common with, say, your emails, you might do Ben testing, and it's a testing email, then it's going to pull that out for me. But we better go and get the rest of the address, and thankfully that's not too much more difficult, so we'll add in exactly that same expression again. that comes after the plus, and then what I'll do is I'll just hit enter again, and you see now it actually does go ahead and extract that, and it extracts the .com because that's part of the word now. Okay, so that's the regular expression to do the email. It's used the same logic here for the second half, just to say extract any word that follows the @ symbol, and it has lowercase, uppercase, 0 to 9, underscores, pluses, dashes, and most importantly of all, it can contain a period. Now, this is fine, it will extract your email address. What it doesn't do is, if I had this, for example, then it won't let me know ever that this is not a valid email. So we might actually want to just extend that to actually test for that. So let me show you another example with the reg extract of extracting an amount from a string. So again, we'll do reg extract, and this is our text, and this time the regular expression is going to be anything from 0 to 9, and we need to put the quotation marks around it, and we'll have a plus, and then we'll end quotation marks, and it says any of the numbers from 0 to 9, and we must have one or more of them. So let's just hit enter, and what it does is it extracts that 6. It doesn't go very far because there's a comma. So we need to add that comma in. So let's add that comma in, and there we go. Now extracts that whole number for us, and nice and easily we've extracted that number. So if we just go ahead and just change the number, let's say it was just 700,000, it will just extract that. If it was simply just the 90, it will extract that. If it had no commas in, it would still extract that number. And if it had some multiple commas in, it will just extract that number still for us. So let me go back to a real number again. And what we want to do is actually just remove that comma and turn this into an actual number, because it's still a text string. And if I just try doing value, it's recognizing that that's an actual number. So if we had 9,755,500 and hit enter, then you'll see it turns it into it actually pulls it out as a number for me. Okay, so that's extracting the number. Let's see one more example, extracting something from the social media statistics. So it's extracting some data from a text string again. And I'll just copy this in, and this is my Instagram handle, and here's a formula that extracts the data about my profile, so how many followers I have, how many people I follow, how many posts I've posted, etc. So you might use this in your social media research if you're a digital analyst. And I have a lesson all about this import formula up here, but we're not going to go through this in this lesson. That's covered in the other lesson. What I do want to say in this lesson is, how do I extract the 140 followers, or the 339 following, or the Ben L. Collins, say, for example. So let's take a look at how we would do the regex there. So we'll say reg extract. So we're going to do a reg extract. This is the data, the string that we're going to search through. And what we need to do now is actually do some grouping, because I'm going to do I want to extract the 140, not the 140 followers. I want to extract the 140 followers, which means I need to say identify followers, but then not actually extract the word followers. And I need to do that with these groups, because I can set up a group that says find this, but don't extract it. But let's go ahead and just extract the 140 first. So it's going to be a straightforward number extraction. So 0 to 9 and a plus and any commas. So that will get me the numbers. And then I want to find the followers, and the way I make sure that they don't return this is to put the question mark and the colon and the space, and then I say followers. And the space, actually, sorry, is that space before followers. So it's the question mark and the colon here that tell me this is a group to find but not return in my reg extract. Again, like I said, the reg extract or the regex formulas are difficult. Regular expressions are hard, so this is going to take time to settle in. So I'm really just showing you a few things, and it's really the onus is on you to dig deeper into this topic and learn more if you want. And one day I might actually do a dedicated regex course, so keep an eye out for that. So we'll close that parentheses, we'll close this bracket, and we'll hit enter, and there it pulls out the 140 for me. Let's just wrap it with a value, which will turn it into an actual, align it for me and tells me that that's now a number. So let me lock that. Let me copy that down, And let me change this from followers to following. And there it pulls up 339 for me. Same again, we'll put it here and we'll change it to the word posts. Extracts to 306. And as a final example, let's just extract this Ben L. Collins. Now, there's various ways you could probably do this. You could use search for the @ symbol and anything after that. What I'm going to do is show you how we extract it based off returning whatever's between those two parentheses. So let's do that. So we'll say it's a reg extract. This is the text to extract from, and then the expression is open parentheses. I want to do a backslash and a parentheses, which means, hey, this is actually, I want you to search for parentheses because I've used the escape character rather than treat that as one of the regular expression terms. I want you to actually search for it this time. And then here's the regular expression term, which is find the group of anything inside of the whole group inside of the brackets. And then I need another escape character and find that final parentheses. And the reason I use this group in the middle here is just to extract what's in the middle, not to extract the two parentheses as well. It finds them, but it doesn't actually extract them. Then I close this parentheses, hit enter, and it extracts that Ben L. Collins for me. So that's pretty nice. Let me now show you, last of all, let's just have a quick look at the regex replace and see how that works. So it's the same as the regex extract, but what it does in fact is rather than just extract that data, it just replaces it with something else. So let me give you an example. Let me say we have this string here, and what I want to do is replace this email address with the correct one. And so what we'll do is, first of all, we'll just find it. So we'll do regex replace. Here's the string I want to search in. So we could use the same logic we did with the earlier email string, which said go and find the email using this expression, which means anything. So there's the @ so it's going to find an @ symbol, and it's going to find anything before that that's lowercase letters, uppercase letters, numbers, underscores, dots, pluses or dashes, and there's going to be at least one of them, so one or more. And same again after the @ symbol is going to come the same, lowercase, uppercase, etc. But it won't include these parentheses because they're not specified in my expression, and also it's going to stop at the space as well. It won't go as far as, it won't include that space because I said don't include spaces. So that will find me the email address, and then I want to replace it with ben@benlcollins.com. And let's see, and there we go. It's replaced that string now with the correct one. So it's used regex to find an email address and replace it with the correct one. So we could have, say, another underscore test dot user dot 123. If I had a strange email like that, it will still work, and it will still just find that email address and replace it with the Ben at Ben L. Collins. That's a quick whiz around the regex formulas. Let me show you one more thing before we leave, which is to just show you this page here, the Google RE2 repository, and this is on GitHub, and I've got a link to it below. And this is the reference for this regular expression stuff. It's pretty dense and pretty hard to understand at first, but this is really important for reference. So there's the 0 or more that we've been talking about a lot, the star. There's the plus, which is the 1 or more. A question mark can be 0 or 1. So there's lots of things up here to go and check out. So that link's below. That's a quick look at the regular expressions, and hope that hasn't given you too much of a headache. Thanks very much for watching, folks. So let's talk about spark lines. Now these are really fun. What they are miniature little charts that exist inside of a single cell, and they were coined way back in the 90s actually by some interface designers, some visual interface designers, to add some extra emphasis to trends and stuff like that on dashboards and things. And the term sparkline was coined by Edward Tufte, the statistician and data visualization legend, and they've been pretty popular ever since. So let me show you what they look like. I have some data here with just 10 days worth of product sales, and what I'd like to do is just see sales look like and understand just really what they look like. So we type sparkline, I highlight the data range, and I hit enter, and it gives me that line, that trend. And I can see these ones all go up, these ones all go down, these ones drop as well, these ones are all over the place, and then these ones are all over the place as well. You can see with the sparkline that it gives you an instant impression of what that data is doing, much better than just looking at the plain old numbers. And we can take it even further. We can actually, I'll show you this one quickly, and then we'll see some more detail about the sparklines. But this one, just to be very quick here, chart type, column, and this time it'll be depicted as a column chart, showing the same data. So that's what a sparkline is. It's these charts inside of a single cell. They don't have any axes or context, so you need to just bear in mind that they just show a trend of your data. So there are 4 different types of sparklines in Google Sheets. So sparkline, let's highlight the data, let's lock it, and actually the default is the line, but we, just to be pedantic here to show you the syntax, we'll specify it. So we open with a curly bracket for the options, we type chart type, and we do line, and then we close the curly brackets. And it's important we say chart type every time, and then we have a comma, and then we choose what type of column or what type of sparkline it is. And I'll go into more depth with these options in just a moment, but the options live inside of the curly braces there. We hit enter, and that gives me that line chart. So as you can see, there's 4 lines there. And as I said, you can actually, for the line chart, because it's the default, you don't have to actually explicitly say that one. But for the column, we can change the chart type to column. Gives me the column there of the data. You can see the negative ones are pointing downwards, if you like, and the positive ones are upwards, so it almost sort of implies an axis of 0 there. Then we have the bar, which is the horizontal version, and this looks a little strange here, but what it's doing is it's compressing all of that data, if you like, into points in a single horizontal chart, and the colors alternate between blues and oranges. So it's not actually really, you'd never use a bar chart, I don't think, with this kind of data like this, because it's not really easily depicted. But we'll see some examples a little later on that show you when you would use a bar chart, and when it makes more sense to use a bar chart. And then finally there's the win-loss. So let me just show you that one. And all that does is just give you a positive or negative number, a +1 or a -1. It looks at the data here. Anything that's a negative number gets a -1. Anything that's a positive gets a +1, and then it just gives you that printout as a win or loss type chart. You can go into real detail with these options in terms of customizing sparkline charts, in terms of the colors, the sizes, the thicknesses, all that sort of stuff. So let's take a look at that. So I have here a column of data, and what I'm going to do is run through all of these formulas, each one in turn, and just let's take a look at what they're doing. So I'm going to copy that into here, and we'll just see what this one looks like. And it does, as we've seen, it's just the standard column charts. So that's all this one does. Let's try this one now. Now this one, if you look up here at the options, what I've done is specify chart type, comma, column. So the chart type, then a comma, and then the next attribute of the chart type, which is the column, and then it's a semicolon to separate the next attribute, which is the color attribute. So I have a chart type attribute, which is a value of column, and then a color attribute with a value of red. And so you use the semicolon there to separate them, and you include them inside of the curly braces. Now you're not limited to just the standard colors. You can use the hex notation, which is a way of specifying colors with the the hexadecimal notation, so you can get really creative with your colors. We can specify low colors and high colors, so let's take a look at that. So in this one I'm going to denote the low color, that -28 there with the red, so it just stands out. Similarly I can do the high color, and if I copy that in, and then the high color will be red on this one, and you can see that again what I've done is separate these attributes with a semicolon, and you can have multiple ones. I could have a low color and a high color marked, and they could both be different if you want. So I'm just showing each one in turn individually so you can see the effect of them, but you can put as many of these together as you like inside the options. You just separate them by the semicolon. So here's the first color, we have the last color, that's another one that we have available, so we'll drop that in there. Then we can highlight negative colors. So all of the negative values get highlighted red on this one. So you'll notice that there are some empty cells in this column of data, and what we have is we have this attribute called empty, which allows us to specify how we want to deal with those. And so far the default is to actually ignore them, but what we can do is say, hang on, set the empty ones to 0. So you'll notice that they actually now show up as zeros. They actually have the gaps, whereas up here they didn't. And if we have actually, we can actually specify if we specifically want to make sure that they just are ignored, we can just ignore them, and you'll see the difference in those two charts there, where these ones don't get included. Similarly, for anything that's not a number, like these three texts, we can decide whether we want to convert it into a 0, like this one. Let's take a look at that, and you'll see that it gives that gap of 3, which is those three text ones there. So it comes after the 6 but before that 30, and then also we can also just choose to ignore them, which is the default position anyway, if we like. So that would be that one. You can see that now they disappear, those 3. So you can decide how to deal with zeros and text. You can actually explicitly say that, so rather than just leaving it up to the sparkline to automatically choose, you can determine that behavior. We can actually put in a horizontal axis. It's hard to see on this one, but there is actually now a horizontal axis added there. You'll see it on this next one. We can actually specify the color of that horizontal axis. So let's just put that in, and you see now it's red, and so I can really be a little clearer if I want to denote between the positive and negative, but that's about as far as you can go with axes in Sparkline. So you can't add values to them or anything like that, because that would kind of go against the whole philosophy of the Sparkline, which is to be as simple as possible and really just to show the trend in a single cell. We have this one called the Y minimum now, which is where we can set the minimum Y value. So I've said Y min here as an attribute, and I've set it to 0. Now you can actually use formulas in here as well, if you like. So you could set it to be the minimum of something, of a range, or the maximum of a range, that kind of stuff. But we'll leave 0 for now. I'll hit enter, and you'll see what it does now is it omits all the negative values. It just leaves them as 0. It sets them to 0 if they're effectively, if they're not, if they're negative. We can do the same thing where we set the maximum, the Y maximum, to a 0, and put that in. And this will do the opposite effect, where it just only shows rather the negative values. And then the final one I'll show you is just to reverse the data from instead of running from left to right, we can reverse it, and it runs from right to left. And we'll see how easy this is to see. So if you look at the very first Sparkline and you look at this last one, then really it's just the mirror of this Sparkline. So you'll see it starts with this one below on this side now and runs that way through the data. And so that's the attributes there. That's how all the different attributes we have for column. And like I said, for the line charts, we have things like the thickness, and the bar charts have a slightly different notation for setting colors. So I've added some links here where you can get to the outline of all of the different options, but we've covered sort of 90% of them here. So there's only a few others, and I'll leave those for you to check out. Okay, so here's another example which will just allow us to understand the bar chart a little more, and it's a little more complex. I've got some positive and negative values in this list, and I'd like to create this kind of progress indicator type bar within this cell, which tells me how far through the task I am, or maybe how far behind I am, or whatever the measure is representing. And let's see how we actually do that with this Sparkline. So first we'll just do sparkline, we'll do A2, and we want to do a bar chart, so we'll do chart type bar, and if we just copy that down now, then it's not very meaningful. When you have a single value, obviously all it's going to do is just say that value fills the whole cell, so that's not really helping as much. So we need to just add in a max at the very least, and let's just add in a max of 200 and see what that looks like. And that's getting a little closer now, at least they have values, but obviously the negative ones are still showing just as a value. It's 88 out of the 200. It doesn't automatically just flip it to the left hand side of a imaginary axis. So what we need to do, we actually need to sort of say, okay, well, how far back, where would this axis lie? And I've looked at this problem and I've said, okay, well, what's the max of all these values? And you could do this just with your sight, with your eyes for now, but maybe if this was a bigger list of data, you might want to do these min and max formulas. So that would be 193 and then minus 88. So let's take bounds of 200 and minus 100, as in everything will be below 200 and everything will be above minus 100. So that would give us acceptable, if you like, right and left boundaries for our set of charts. So that's sort of why I use that max of 200 over there. What we would like to do effectively is shift the positive numbers across by, because if this is the minus 100, then if I add 100 to them all, that would get me to a 0. So that would be this line through the middle, and then I would have up to 200 then value to play with. So what I'd like to do is actually just shift this one along by 100. And so what I can do is actually say, okay, well, let's just build a little data set. And again, this curly bracket notation is maybe familiar to you if you've watched the array lesson or you've seen them before, but if you're not familiar, then the curly brackets just create an array. But I can just do this construction here where I can type a number, then I can choose a cell, close the curly brackets and hit enter, and it gives me a little range of data there. So let's actually just plug that in to my sparklines here, and you'll see now if I take all these down, you'll see that actually now they are all starting from 100. They all move in at 100, and then they have this max of 200, except the 200 now it's the max of the overall, and so that's 100, and that's why this is actually getting cut off, because the 113 has now gone beyond. So we need to change this to a 300 to make sure that we actually get those values showing through, because the 100 is a third the way through, the 300 is the max of the entire data box, if you like. So we've now got that set up, and you can see that the orange now is representing where I had my these whites before, these blanks, so we'll come back to that in a moment. Now what I'd like to do with this one here, for example, is use the property right to left, and we'll set that to true, and what that does is flip it round. And you'll see with any of the negative ones, what I want to do is flip that round, and then you'll also notice though that this now no longer kind of lines up. And so with this one, what we need to do in fact is start this one, the 0 now, because we're looking right to left, the 100 isn't coming in far enough, it needs to come in 200 now. So what I would do is I would actually have to have this construction, and I need that final, close the parentheses, and it comes in 200, and then it has the minus 88. And what we'll actually do is, as well, is actually we will change the minus 88 just to a positive number, because we don't need that. The minus is not represented or not used in the sparkline as such. So what we'll do is we'll switch these negative ones to a 200 and an absolute of the 88, and that way if we just do that just for the negative ones, you'll see that we now it's now starting to look like it was here. We just now need to specify some colors, and so we want color 1 to be white. That's the key, so let's put that in here. And then we have now, so this is the positive one, so let's put that in here, and then in this one here we'll have color white, and don't forget my semicolon there. We'll hit enter, and that's now given us exactly the same shape as what we had before, and now we can just specify a color 2. So the second color of the bar chart, and we'll do green obviously for these ones. And there's my green, and then we'll do red for these ones. So again, semicolon to denote another attribute, color 2, comma, and then red for this one. And we'll copy that down, and we'll copy that down, and now we're looking pretty good. We've got the two formulas set up. Now the only thing we want to do is just to combine them so that we don't have to keep making this change. We want an if statement to just decide whether it's a positive or negative and make that adjustment for us. So let me copy this sparkline formula, and then let's just say, let's go back to this first one and just say if A2 is greater than 0, then use that sparkline that we have already. Otherwise, use the negative version of the sparkline. Let's close that parentheses, and then we can now just copy that same single formula down. And I see I've made one mistake there, which is A2, and this should be an A2 as well. It wasn't on the same row. That was the issue there. Okay, so what I've done, just to recap, so we've said if A2 is greater than 0, then we're going to be in this first sparkline section, which is this one here, and we're going to say that it's give me the first value of 100 and the second value of whatever the data showed, and make the first value white and make it 100 in, and then the second value can be green, and so that gives us that sort of impression of the axis. And then the second one we said give me a value of 200 and then whatever the value, the negative value was, but we'll take off the negative, and then this time flip it round, and then the 200 comes in from the right hand side, lines up with where the 100 was from the other side, because the width of it is 300, and then gives me the negative value there. So that's how that works. And really, I mean, a pretty specialized use of the sparkline. I just wanted to show you that you can get quite creative with them, especially when you start to apply these sorts of techniques to your data. That's everything I wanted to show you with sparklines. There's resources below the video, and thanks very much for watching. Let's take a look at the indirect function and the offset function, two hard-working little functions that we often use inside of larger formulas. So I'm going to show you a couple of examples for each one. So let's dive into the indirect here. Now, the indirect function converts a text reference, so a text reference to a cell or range, and converts it into the actual proper active cell or range in your spreadsheet. So it can be really useful for the example here I'm about to show you, where let's say we have some data for across a number of years or product categories or groups, and they're in different tabs like this, different tabs within our sheets. But what I notice is it's actually the same table, it's the same group of cells from A1 through to B5 each time. So I can use that property there to now go ahead with my drop down here to just create a reference. So if I'm choosing 2016, it will point to this data. If I'm choosing 2017, it's going to point to the 2017 data. So let's see that, what I mean by that in action. So first of all, we'll just highlight that cell there, which is the one I've chosen. Do an and then we'll do a space data, and then this is the sheet. Then this becomes now a sheet reference, A1 to B5. And so if I change this to 17, it's going to change that reference there to 17 and 16. So that gives me now a text. That's what I mean by a text reference to a range. It's a static piece of text in a cell. So, you know, for example, A1 would be another example. In fact, this even is a little simpler. So let's just do A1 before I come back to my main example. If we do indirect now of A1, it just gives me the value that's being shown in A1 there, which is that piece of text string that I have. So I can now use this indirect here to say equals indirect and click that reference there, close that parentheses, and now it just actually gives me the actual values from the 2016 dataset here, because I'm now changing this text reference into a proper reference, and it just pulls them through for me. So if I change to 2017, it updates these values to the 2017 ones. And so I can then use that in this little dynamic lookup, where I can say VLOOKUP product A in this range, this range here, turn the second one, and we'll go for false, and it gives me then the answer of 5. So the product A in 2017 had a value of 5. Now I can actually embed this each step in, so I can take this one, rather than link them all to the previous cells, I can embed it into that one like that, so that now, if I delete this reference, that doesn't matter, that doesn't go away. And then finally I can take that indirect, do the same thing, and just dump that directly into my VLOOKUP there. And then it doesn't matter if I actually then go ahead and delete that one. I can say, okay, what did product A give me in 2016? It was a value of 1. What was product C? It was 3 in 2016, and it was 7 in 2017. So you can actually do some pretty nice things with the indirect there without needing to actually have those intermediary tables. One other thing we do with indirect that's probably more useful for you guys for the advanced formulas, and we've seen this already in one of the other videos on the row and columns, so I will just quickly recap it here or show it to you for the first time if this is the first video you're watching. Let's say I wanted to create a vector, so that's a number of columns that was sequential, 6, 7, 8, 9, etc. down to 10. You know, rather than type it in like that, I want to have this vector available to me in my array formulas so that I can do some further manipulation of my data and maybe sort the data or loop over the data, that kind of thing. And so quite often you need to create these vectors. And the way we do it is by, first of all, we can create a text reference to a number of rows. So we say what rows 1 to 10. Then I can use the indirect function wrapped around that to actually pull the data back, and you just see that that's just giving me the values there from 1 to 10. And then I can actually then just change that, wrap that with a row, which gives me those numbers 1 to 10 rather than the actual data from 1 to 10. And I need the array formula just to finish that one off. And there it gives me a nice row from 1 to 10. If I change this to 6, say, then okay, I see what, if I actually change that to reference that cell there, then I can change it dynamically to give me whatever size vector I need for my calculation. So that's another example of using the indirect. So let's take a look at the offset now. That was the other one I wanted to talk to you about in this example. And the offset, what we do is it just offsets, it literally does what it says on the tin. It just takes a range and it offsets it by a set amount. So if I give you a very simple example, we'll take a cell reference of A1, and you can see it's giving me the help here. What's the offset? How many rows do I want to offset it? Let's say we'll offset it by 5. How many columns do I want to offset it by? Well, we'll say 0 because I've got nothing in these columns, so I don't want to move my... So it's basically, where do I want to move this orange box to? So I want to move it 5 down, so 1, 2, 3, 4, 5. It's going to give me the value of 6 there. And so I don't want to move the orange box across any columns because I have nothing in these columns. So we'll leave it at 0 there. And then what's the height and width? So let's say we want to just bring back 3 values, and the width is just 1 because it's one single column. So I want to return those 3 values there, 5 down from wherever my offset was. So I start with A1, move down 5 to the 6, and I pull out those 3 values there. And that's what the offset is all about. So we can use it to do certain specific calculations. So for example, I have this data set here, and I've color coded it just to help make this a little clearer. Let's say I want to sum up the first 4 with the formula, and the second 4 with the second formula, and the third one with the formula. And I want to just create the same formula so I can just drag it down. And like usual, we'll build this up with in stages. So first of all, I need to know what the offset is. If I'm going to start with this value here, so what's the offset from here? For the first 4, it's 0. I don't want to go anywhere. I want to just start there. So we want an offset of 0 for that one. For the next one, I want to come down 1, 2, 3, 4. So 1, 2, 3, 4. So 4 for the next one. And then same again, another 4. So it would make it 8 for the start of that one. So the way I can do that is to go, I can take my row, which gives me 2 here. Let's just see what we get for each of these. 3 there and 4 there. So let's multiply that by 4. And that now gives me the gaps I'm looking for. So I have now a gap of 4 between those ones and 4 between these ones, but it isn't giving me the right values yet. So I actually need to just come back in and need to just take off first the little offset that we have already built in, because we're on the second row already. So I need to start with a 0 by removing the 2, because I'm 2 rows up. So I need to just take those 2 off, give me the 0. Next time then it gives me the 4. So this row is row 3, minus 2 is 1, times 4 is 4. This row here is 4, minus 2 is 2, 2 times 4 is 8. And that gives me then now what my offset is. So let's go ahead and actually see that offset formula now. So it would be offset, and we'll start with that one. And then what we want to do is offset it by this formula we just calculated, which was row minus 2 multiplied by 4. And then the offset number of columns is a 0. Then the height is 4 and the width is 1. So that gives me 1, 2, 3, 4. Let's see what happens if I put it in that one there. We need to just lock. Let's just lock that E2, because I'm going to be moving this around now. Put that one over here so I don't get the error, and we'll put another one over, a copy over here. So first 4, it's going to be that. So let's just now wrap that with a sum. Then I can now move this back to the correct. So the sum of the second 4, that's my vector showing the second 4. Let's just put the sum into that one. And then this now is my third group of 4, which is these ones here, which I've pulled out with the offset, and we'll just sum those ones. And there we go. So there are my sums for these ones. So the first 4 were added up to 10. The second group were 100, and the third group added up to 1,000, and I did that with the offset. Okay, so that's the indirect and the offset function, 2 hard-working little helper functions. So thanks for watching, folks. Let's talk about rows and columns in our spreadsheet, folks. And there are some special formulas, however, that work on those rows and columns and do some pretty funky stuff. So let's take a look at the most basic example. We have a formula called row, and I can give it no arguments at all. Just type it in, and it just gives me just tells me the row I'm on at this moment in time. And similarly, it has a sibling called column, which just tells me which column I am in terms of the number. Now you can tell it to You can give it a value, a range. This is optional, but I could click just somewhere down here and it'll tell me, hey, what row was that one on there? And it was the 22nd row. So when I hit enter, the value there, the answer is going to be 22. So it's a 22nd row. Similarly with column, I can select a cell and it'll tell me which column that cell's in. I can also do things like select a whole range of columns and it'll still just tell me what the first one is. So which column does it start with and where does it end up. Now if I hit array formula with this, then what it'll do is it'll tell me you highlighted 10 columns and it'll actually put them all as an output like that. So if I look, then I highlighted from A through to J and I said give me the output of all of those, and it's told me, hey, you selected 10 columns up to J. Now also we have a plural version, so we have this formula called rows, and so if I just hit enter, it's not going to tell me anything. So this one does in fact need an argument. So with this one, what we do now is it tells me how many rows are in a specified range. So if I just select a single cell, how many rows are in that single cell? Obviously 1. If I specify an actual range, so a range of data like that, there are 6. So I selected that there and there are 6 values in there. I can also just omit any column references altogether. Just highlight a whole set of rows like that. Doesn't matter if I'm inside it with my formula. Hit enter and it's telling me there are 25 rows that I had there in my little formula. Similarly for column, there's a sibling called columns, or rather a relative called columns, that just tells me how many columns were there in this reference. Just 1. If I select multiple columns, how many are there? There are 5 in that one. Well, let's go and look at vector creation. And what I mean by this is, say I want to create a sequential number, a set of numbers like 1, 2, 3, 4, 5, because I need to use that somewhere in an array formula. So if we want to create a dynamic version of this vector, because this sort of manual typing in is obviously no good, and we'll see some examples in when we do things like SUMPRODUCT. So step 1 is just to create an actual string of the, which will effectively just be the rows. So we'll say, hey, it's rows 1 to 5, and that's just, if I change this to 10, it's going to be rows 1 to 10. It's just a string representing those number of rows. And what we're going to do is now use that by saying, using the indirect formula, which takes a string as its input and outputs the actual reference, the cell reference. It takes a string and returns a cell reference. So we can say, okay, let's take this range that we just created. So we close that. And oops, we'll need to put it at the end of this number. So let's take that range and make it an array formula. And what it's done is just actually returned all of the values from rows 1 to 10. Obviously not quite what we wanted, so if we just put the row in there now, then what it's going to do is just return the row number instead from those rows from 1 to 10. So that's giving me the output there that I wanted of a sequential numbers from 1 to 10 with just a single formula that I can then drop into another formula somewhere else. If I needed 20 values, then I could just quite simply add in 20 there. If I needed 3 values, I could just have the 3. So that's how we would create a vector. And similarly, if we wanted to have the column version of that, we could just use the transposed version of it. Equals transpose. Drop that in and then hit array as well, and then it gives me there three columns as a vector, a column vector. There's one other way we can do it using rows, so let's quickly look at that. If I type in rows and I just highlight the row that I'm on, and I put a dollar in front of that 30 there to lock it to row 30, close the parentheses and hit enter, that gives me 1, and if I had to drag down, it would give me then all of the different rows there. So again, not really as useful because it's not a single formula that's created that row for me, but I just wanted to show you that construction there of just dropping that in and locking that first one to give me a sequential numbering system. Okay, let's take a look at the sequence function now, which is a really nice function for creating these lists of numbers. And it's also very powerful because there's a lot of functionality. So we'll type in sequence, returns a grid of sequential numbers. And it tells us we start with rows, then we tell it how many columns, what the start number is, and what the step number is. And we'll see all of these in turn as we go through. So let's just close that for now, and we'll just simply do sequence 5. And it gives us a list of numbers 1 through 5. Okay, so let's do sequence, and this time we'll say 1, so we just want 1 row, and we want 5 columns this time. And what this is going to do is give us a horizontal vector. So that's sequence 1, 5. We can, of course, have more than just a single column or a single row. So we do sequence again, and let's do 4. So we want 4 rows and 3 columns. And let's type that in. And you can see what it does is it counts across in this sequential order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the maximum number there. Now, if we want to start from a specific value, that's the third argument that we can specify. So sequence, let's do 5 rows, 1 column, and start at number 100. So I'll just pop that open again. So rows first, then columns, and then the start number. So we've given a start number of 100. So we're going to start from 100. So let's now look at using a custom step. So equals sequence. So we'll do 5 rows again and 1 column just to keep things the same. We'll start at 0 this time. So we're going to start at 0. That's the value we want to start from. And we're going to increment in tens. So let's just now enter that. So 0, 10, 20, 30, 40. So that's using a custom step. That final one is where you say how big is the jump from between each of these values. Now, of course, we can make that negative, and that gives us the option to count backwards. So we'll start sequence. We'll do 5 rows, 1 column. We'll start at number 5, and then we'll say that the sequence, the step, is a -1. So each time it increments, it's going to take off 1 value. And that counts down 5, 4, 3, 2, 1 for us. We can do negative numbers. So sequence 5, 1. Let's start at -1 and let's increment by -1. So we start at -1 and then we're going to keep subtracting 1 from that each time. It's going to count down the numbers backwards for us, the negative numbers. So we can even put dates into the sequence function. So we'll do 5, 1. We'll start with today's value and we'll increase by 1. Hit enter, and there we go. It's given us them as numbers to start with. Let's pop up here, format, change them to dates, and there we go. It starts with today's date and increments by 1. We can do decimal numbers with the sequence function, but it's not quite as easy. It's a little more involved. So we'll do 5 rows, 1 column, as we're used to now. Start at number 10, and we'll increment by 1. So 10, 11, 12. Let's make them into decimal numbers now by just dividing by 10. There's a problem. So as soon as you do something outside of the sequence, you lose the full array because you're doing that divide by 10 on the first value only. So of course, what we need to do is Shift Command and enter an array formula. Now we do it, and there we go, we get our decimal numbers. And of course, we can do constant numbers by setting that step to be 0. So we'll do 5 rows, 1 column, start from number 1, and we'll make the step 0. And there we go, 5 constant ones. Okay, so let's look at some more complex examples with the sequence function. So you may want to do something like this, where you have repeating patterns in your numbers. So 1, 1, 1, 2, 2, 2, 3, 3, 3. Can you do that with the sequence function? And yes, you can. You just need to have help with a friend with another function. It's not possible directly with the sequence function. But let's start. So we'd want obviously 9 rows for this one and 1 column. And there we go, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's all we can do with the sequence function. So let's now divide that by 3. Of course, we lose the full vector there because we've done a calculation. So let's turn it back to an array formula. Hit enter. There we go. So that's getting a little closer, we can see 1, 1 there. We've got 2, 2 there, and we've got 3, 3 there. So what we need to do is add in one more function called round up, which will just round those decimal places up to the nearest integer, which in this case happens to be 1, 1, 1, 2, 2, 2, and 3, 3, 3. So there we go. So that's using the sequence function and its friend, the roundup. So let's come down here and look at pattern number 2. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So a repeating pattern inside of a larger pattern, if you like. So let's see how we might do that. So again, we'll do sequence, sequence, and we'll have 9 rows and 1 column again. So what we need to do now is use the function mod. So we come in here, mod does the, so let me open this out. It's the modulo operator, and it leaves the remainder after a division operation. So let me put in the dividend is this one, and the divisor comma is a 3 in this case. And let's see what happens. And what it's going to do is divide each of these values by 3 and tell us what's left over. So when it divides 3 by 3, obviously the leftover part is 0. Now, of course, we need to make this an array formula. That didn't work, so let's make it an array formula. And there we go, 1, 2, 0, 1, 2, 0, 1, 2, 0. So actually getting a little closer to this pattern here, not quite there. Now, what we really want to do is actually add 1, it looks like, to this. And that will take us again a little bit closer. So let's add the 1. 2, 3, 1, 2, 3, 1, 2, 3, 1. So we're sort of close, but we're not quite there. And what we need to still do is, with our sequence, is instead of starting from the number 1, so let me take off that +1 for the moment. If we start from the 0, so let's go back inside the sequence. So we've specified the columns, we'll specify now a 0. And there we go, now we're a lot closer, we're in the right order now, 0, 1, 2, 0, 1, 2, 0, 1, 2. And so now we're able to add that 1, and we get the 1, 2, 3, 1, 2, 3, 1, 2, 3 repeating, which is what we wanted. So that's looking great. Now, what about if we want to use the sequence to generate a range of repeating text? That's also possible. So sequence. So let's say we want to do, let's do 4 rows and 6 columns. So that gives us that output there. So when we have a block of numbers, what we can do is use the text function to turn them into something. So we can specify now the format of the text, and ordinarily you might do something like that, and it turns them all into text. Of course, we need to use the array formula. And there we go. So they're all left aligned now, which means that they're being treated as text. But really, what we want to do is obviously have something more than just this number. So what we can do is actually add on some more text. So you might say, that is the number I chose. Close off the brackets, and there we go. And you see how it's added all of that text there. But that's not particularly useful. We don't want to always have to have those numbers there. So what we can do is get rid of that 0, and that will just format it without the number showing. And obviously then we don't have to have this particular string showing. So we could have anything we want, like maybe taco. And there we go, we get taco repeating now. Now what's also really cool is that there is a, there is a function called the char function, which we cover elsewhere in this course, that allows you to specify pictures. So we'll add that in, and it allows you to put pictures in your Google Sheets using codes. So we'll see 1277990. Let's hit enter, and there we go. It's added the taco, a picture of a taco, to every single one of these cells. Let me make them a little bigger so we can see that. There we go. Make them all the right length. Perfect. And there we go. So we can add pictures, we can add text, using the sequence function. The char function is covered elsewhere in the course, so go and check that out in the very final lesson actually. But that's how we would add a sequence with text. And that's it, folks. That's all I want to show you with the rows and columns. Let's talk about the formulas small and large. Two pretty small, humble formulas, but they do have a large contribution to make. So let's go and check them out. The use case for the smallest is to literally find the smallest value inside of a data set. And why wouldn't we use the min? That's a good question, and I'll show you why in just a moment. So I have some data here, some products and the revenue per product, or the price or the cost, whatever it might be. And I can use a formula called small. Take a look inside this data and let's log the data and then say whereabouts in the list from smallest to largest, how far in do you want to go? If I put a 1 here, it's going to be the smallest. If I put a 2, it's going to be the second smallest, the third smallest, etc. So let's put a 1. Then, so that's the $65 there, product 17. Let's just drag that down and let's take a look at number 2 and then a number 3 as well. And they're the 3 smallest in my data sets. Now I can also do large, exactly the same. We'll lock it, we'll do 1, and this is the largest, and we'll change it to a 2 to be the second largest, change it to a 3 to be the third largest. So pretty useful formulas, just straight off the bat. We might want to sum those up, and let's just take a look at those values, $396 and 16,000. Let me just format them. There's a quick table of the 3 smallest and the 3 largest in my data set and sum them up. We can, of course, do this with an array formula, so let's quickly just see that. So I'll do small again of the data set, and this time I want numbers 1, 2, and 3. And if I just hit enter now, I'll only get the first one. If I hit array, enter, so Control Shift Enter or Command Shift Enter, I get an array formula. And then this 1, 2, 3 construction is a vertical vector 1, 2, and 3. That curly bracket notation is discussed in the array formula lesson. And what this does is it will just pull out, then you can see it's those same 3. And I could quite easily wrap that in a sum as well and just go direct to that sum if I was so inclined. And I can do the same thing for the large. So if let me lock that, copy over there, and we'll change that small to large, and it will get me back that same answer as I had above. So that's using the array formula method to do it. Let's keep going. Let's take a look now. If I wanted to take a look at finding the smallest number where the number was specified in a cell here. So maybe it was the smallest 5, the smallest 10, and this number varies. So let's see how we would deal with that. So the first thing I want to do is just to show you we're going to use the row and the indirect formulas, which are ones we've seen in other lessons, and the array formula. So all of this feeds off other lessons. And what I'll first do is just do a 1, and this number I've got here. So that's saying 1 to 5. So what we'll do is we'll now turn that into, use an indirect with that. And that now brings back rows 1 to 5. So you can see that's this data is coming from up here. Excuse me. So this data here is coming from up here. So if I have only 3 or 2 or even just 1, you'll see that it's bringing back the data from up there. Then I want to now go row of that, and it's going to just tell me there's 1, but if I do an array formula, it will give me 1 to 6. And that's the same construction then that I've had up here, where I just manually inputted that. Effectively what I've done is just grown a vector, created a vector or an array there of 1 through 6 counts, and so now it's very easy to just say, okay, so give me the smallest of my data set, which was this one. Let's lock that. So we'll lock that. Then here's my vector, and then this now I need one more parentheses to close, and that should give me the smallest 6 values. So if I change this to 3, we should see those same 3 values up above, and I can just wrap that obviously then in a sum as well if I wanted. And that would give me 396 if I wanted to sum the 5, the 8, the smallest 10 if you like. So you know, you can get pretty creative with this, and it's a pretty useful formula. So let's just lock D10, since D10 is the variable there, and copy that across, and just change this from small to large, and just check that works as well for the largest. And that's now giving me the same value there with that method or with that method, and it's the 16,000, which is the full value of the largest 3. Now I did this with an array formula and a sum. There's one other way to do it, which is to use a sum product. So if I just extract again this middle of my formula here and hit enter, that gives me the 65, which is just the first one of those. But if I wrap it with a sum product, then what it will actually do is it will calculate the array, the full vector of the 1 through to 3, and add those up and give me that same 396 there. So it's doing exactly the same as the array formula sum. It's just a sum product. It's just calculating each. It's taking the vector 1, 2, 3, which I created, and that's this bit here. If I just extract that quickly. So if we put that just over here for the moment, and we just Control Shift Array, then that gives me the vector there, 1, 2, 3. What it's doing is it's taking the smallest one, then the smallest second one, and then the smallest third one, and adding them together. There's no multiplication to do because it's just a single array, so there's no second array to multiply by, so it's simply just adding those together. And that's the sum product. But it allows you to do, without having to use the array formula, it allows you to do that array calculation. So that's with the sum product. Again, if I just copy that over and we'll change small to large, we'll see it gives me the same as the 16,000. So that's using the small and large there to do some pretty nifty calculations. And that's the small function and the large function, a little introduction and some use cases for them. So thanks for watching, folks. Time to get your thinking hat on, folks, because we're going to be looking at some matrix multiplication in this lesson. If it sounds scary, that's because it is scary. We're going to be looking at a formula called mmult, which is matrix multiplication. And just a quick recap, we're going to look at the transpose function as well, which we may or may not have seen already, and you may not or may not be familiar with. That one's very easy. So we'll start with transpose because that's the nice easy one. So if I have a column of data and I want to change it to a row, I can use this formula called transpose, highlight the range, hit enter, and it changes it into a column for me. I can also take columns. So if I have this data here, rows, I can take a row there and transform that into a column. So it's a nice way when you're working with complex formulas, especially array formulas, and you're working with row or column vectors, but you need to flip them one way or the other to complete your calculation, then a transpose is a really handy function to remember. So it crops up a lot, so it's a good one to know. And you don't have to just have single rows or columns. You can it works equally well with ranges over multiple columns. So we can just quickly, let me center all of those. We can quickly transpose all of those into two rows like that. So that is transpose. Very quick run through that one. Let's move on to the scary hard matrix multiplication, the fun of the mmult function. So a matrix is a range like this. It has multiple rows and multiple columns. And this example here in matrix 1, this range has 5 rows of data and 2 columns. So it's a 5 by 2 matrix. Now matrix 2 over here has 2 rows and 3 columns. So this one is a 2 by 3 matrix. And if we want to do matrix multiplication, then the number of columns in matrix 1 of our multiplication must match the number of rows in matrix 2. So I can multiply 2 columns here against 2 rows here. So let's make a note of that so I have that fresh in mind. So in standard matrix multiplication, the number of columns in matrix 1 must equal the number of rows for matrix 2, which we've seen. And the matrix output is the size of matrix row 1 rows, so that's 5, and the matrix 2 columns, which is 3. So we should see a 5 by 3 matrix when we multiply this lot together. So let's see that in action. So we use the formula mmult. We give it the first range, and we give it the second matrix. So I just brought the helper pane up there just to show you what's going on. So it has 2 arguments, the first matrix and second matrix. And if you remember, the number of columns in matrix 1 here must equal the number of rows in this matrix 2 for it to work. Otherwise it'll give you an error message. So we'll hit enter. And now we have our nice 5 by 3 matrix. So what's happening? Let's have a talk about that. So the first thing it does is it takes the row 1 here and multiplies it against column 1. So it's that 1 by 3, and the 1 multiplies against the first element, the 3 multiplies against that second element, and then they get added together. So 1 by 1 is 1, 3 by 1 is 3, that makes 4, which goes there. Next up, the 2 by 1 multiplies by this first column here, so second row against the first column, so that's 2 times 1 is 2, plus a 1 times a 1, which is 1, that makes 3 total. Then we do that one against that one, then that one against that one. You can see that one will make 5, then that one against that one. And then I move on and run through all 5 again against the second column, and then I move through and do all 5 again against the third column. So for example, this 21 in the middle here would be the middle row here. So the third row multiplied against the second column there, and it's 1 times a 1, which is a 1, and a 2 times a 2, which is 20. Add them together to make 21 to go in this cell here. And so that's all it is. It's a bit daunting at first, but once you get the hang of matrix multiplication, it's not that tricky. So I'm going to show you one example here about how we could create a running total for these values here, and how we can use the mmult function to do that. So obviously if we were to do this manually, the running total would be that. The first one would be 1, and then we'd add the new value to the value above, and we'd just keep on dragging that down. But then what we'd have to do is, if I added a new person in here, so Bob, and he had 8, then it doesn't automatically update. I have to go in and copy the formula down, and also, or even, you know, drag it down so it's sitting there. So you could put an if statement in there, but again, what we'd like to do is actually just have an array formula that was our running total, so that I could have one single formula here, so that anytime I added more data, it would just simply update that running total and just keep that going for me. And we can do that nicely with an mmult function. So let's go and check that out. So what do we need? We need to create two matrices that we can then multiply together. And we're going to do this in stages again, and we'll just go ahead and create matrix 1 up here. And this is going to be a little bit convoluted, but just bear with me. Just keep going through to the end and you'll see, I think, how it all comes together. So let's just start with the formula equals row B2, and we'll just go down as far as B10 to keep things simple, because otherwise these formulas get very large. But when we're done, we could just simply remove that 10 so that we don't, this range goes all the way to the bottom of our data set, of our sheet. But we'll start with just B2 to B10, and let's just add an array formula by Command Shift Enter or Control Shift Enter on a PC. And that gives me then just simply the row number. Now let's use our friend, let's just transpose that. So I come inside the array formula there, put the transpose in, hit enter, and now suddenly that moves those all across to a single row. So I've got now columns instead. Okay, so that's part one of the formula. Let's leave that in place there, and let's now also just keep a copy of this original column vector we had. What I'd like to do is just know whether this area here is, whether these ones here are less than or equal to the row across the top here. And we'll sort of fill this in if you like. So let me just show you that, and then you'll see, you can see what I mean a little easier once it's actually. So first of all, I'll just put that in, then I'll take this one here, and really all I want to do is just say, is this less than or equal to? And now you can see I'm saying, let's also just do some quick conditional formatting. So for example, this row here, what I've said is 6. Take the value 6 and we'll test against 2. Is it less than that? No. Less than or equal to 3? No. Less than or equal to 4? No. Less than or equal to 5? No. Less than or equal to 6? Well, it's equal to 6, so that's true. It's obviously less than 7, 8, 9, 10, etc. So that's how I fill out each row, and that's a single formula here that's now doing that for me. So let's continue. Let's now actually multiply that by the values here, because that will then turn these trues and falses into something much more useful. So what I'll do is, rather than, we'll leave that matrix there so you can really, we can see this really in stages, and we'll just make a new copy down here. We want to make sure we don't have two. So we'll just get that set up again. So that's the same, just a copy of that. So what I'll do is I'll come inside of here. We need to put some brackets around this first. Then I can multiply it by B2 to B10, and then just close that last bracket off with the array there. And what it's done is it's changed all of the trues and falses into numerical values based off here. So when it tests when it's a false, it will just put zeros, and when it's a true, it will put the corresponding number from over here. So I've now got a matrix, and the one last thing I'd like to do with this one actually is just transpose it, because I want my ones to be all down here, and the twos, threes, etc. across. So I want to just transpose this one so that it fits. It's the right format for when we're doing our matrix multiplication. So we just need an extra transpose around this one. Hit enter, and you'll see it's just flipped it around. Okay, so now I have my matrix 1 ready. Let me just let's clear out this one up here. Also get rid of the true false conditional formatting there, and we'll move this one just up there so that matrix 1 is up there and out the way. And let's go ahead and create matrix 2 now. And matrix 2 is a lot simpler, thankfully. So we'll just use the formula called sign, and it returns a -1 if the input number is negative, 1 if it's a positive number, and 0 if it's 0. So let's put in B2 to B10 again, and then hit the array formula. And you'll see all it's done is just change all of these to 1s and then 0s for those last two that were empty. So I've now got an array of 1s and 0s, and now we can do the mmult, the matrix multiplication. But let's first check that we have the right size matrices. So if you remember, we needed the same number of columns in this one as rows in this one. So I have a 9 by 9 matrix here, and I can multiply it by a 9 by 1. I have 9 columns in this one and 9 rows in this one. So yep, we're good to go with the matrix multiplication. So let's do an M mult. We'll do that one here, and we'll do M mult, and we'll do this one here, multiplied by this one here, and we should end up with again a 9 by 1 matrix from it. And so what it's done is it's actually just calculated now our running total effectively, because we take our first row here, multiply it against this one, and obviously it's just a 1 against a 1, and then everything else is 0 because of these zeros. The second row here we multiply against here, and that gives me the 3. So it's a 1 times a 1 plus a 2 times a 1, and then a 1, 2 and a 3. Add them together gives me the 6, etc. So let's just finish the whole formula off now and put it actually back up here into our running total column. So we'll just copy it. Then we'll go ahead and actually grab the 2 matrices we calculated rather than just reference the cells. So we'll put that one in there. Now I have to hit enter again to make sure it's an array formula. And then the second one was this sign. Let's copy that, and let me just open this out. We'll drop that into my array formula. Let's just get rid of that line there, and we'll hit enter again, and that's my running total. And then the one last thing I want to do is just to not show it if these ones are blank. So that's very easy to do with an array formula. So we'll say if b2 b10 give me this answer. That's the end of that. Otherwise, what do we want to do when it's false? We could just leave it blank. That would be one way. We can use this construction if error 1 over 0, which gives me the error, and if it's an error then that just puts nothing into my cell. This guarantees an error, 1 divided by 0. If it's an error then just put nothing into the cell. That's the nicest construction you'll see sometimes. And there we go, it's now done that calculation, and the running total now is in place. As I said, let's actually just change all the tens to thousands now, so it goes right down to the bottom of the data sets. Excuse me. Hit enter, and then now when I add in a new person, so let's say it was Jane, or we had Jane already, let's say it was Helen, and she had a value of 100, then it will add in that. It's going to take a little moment to update. There we go, it just adds in that 133 automatically for me. So that's a nice application of the M mult combined with the transpose, combined with the row. So I think our heads are probably hurting enough for one lesson. So thanks very much for your patience and for bearing with me through that. I hope that was worthwhile and you learned something. And thanks for watching. See you next time, folks. So let's talk about the frequency and the rank formulas in this lesson, and we're going to create some fictitious test score data to work with, and then we'll take a look at the frequency and the rank based on that test data. Now ordinarily you would obviously have your exam scores, but in this example we're going to actually go ahead and create those ourselves so that we can then do the frequency formulas and the rank formulas and sort of explore those metrics. And it's also a really nice way, this little aside, that we're about to explore of how do we go ahead and create a realistic data set to go and work with, to do some testing, to set up our models. Because if we just do create some random numbers for these exam scores, it's not going to be a realistic data set to work with, and it's not going to give us any good answers when we start building our models. So we need to create what we call a normally distributed data set. So let's just take a look at the basic example of using the random function just to create some random numbers and see what that looks like, explain why that doesn't work, and then take a look at the normally distributed version. So we'll just simply use the formula equals rand between. So the low score is going to be 1 or 0, and the high score is going to be 100. So it's going to give me a random number between 0 and 100, rand between. Let's make it centerlined, and we'll double click the blue to send it all the way to the bottom of our data set. And there you go, you can see it's just giving us random numbers, random scores between 0 and 100 that these 500 students achieved on this test. So let's highlight them all, Command C or Control C to copy them, right click, paste special, paste values, because I don't want to leave all those random number generators, because every time I do something else, it'll recalculate. So let's fix that. And now let's go ahead and take a look at what the frequency distribution of this data set looks like. So what I'm going to do, the obvious solution here is to put them into bins of 10. So I want to group all of my students that got a score between 0 and 10, group my students that had a score between 10 and 20, 20 and 30, all the way up to 100. That's a pretty obvious grouping. And what we need to do now for the frequency formula is actually just create an upper boundary from these limits, because it won't work with these text, because these are text strings at the moment, because they have this dash and they have the lower and the upper boundaries. So I need to just create the upper boundary, because then that gives me a number I can use in my frequency formula. So we'll do 10, and the quick way to do this is just to simply add 10 to each row. So the next one's 20, let's drag that down to give me all the way down to 100. And now let's take a look at the frequency formula. So we come up to here to F, I'm going to type frequency, and this is going to tell me how many scores from my list of 500 I had in this bracket, then how many I had in this bracket, how many I had in this bracket, all the way through to up to the 100. So my data first, it wants me to highlight, so I'm going to click B2 and all the way down to B501, scroll back up to the top, and I'm going to then, my classes are these upper boundaries, and so when I close parentheses and hit enter, it will now fill those in for me, and it's told me that's what my distribution looks like. And if we were to plot this now, so let's highlight this one, and insert a chart, and we won't do anything else, we'll just close that now, and that's what my exam score distribution looks like with this randomly generated set of data. And obviously that's totally bogus, because if I had 500 students sit the same test, then I would expect the majority of students to probably get something around about the 60% mark, say. Because most students are going to get a similar score, they're all taking the same tests, they presumably all had the same education or teaching leading up to this test, and even if they haven't, they're still going to group around an average score. If we use this model, then it would lead to some very incorrect conclusion. That being said, what we can do next is actually go and create some data that is distributed correctly for the around a mean. Now, one last thing I'll show you just before we go to that step is we can create these histogram charts with one single click. I always prefer to go through the frequency formula so that I then have this data. But if we were purely just looking for the histogram, then I can just highlight my data set here, the whole data set, come up to insert to chart, and we're going to change it from a column chart here to a histogram. And we'll go customize, we'll go histogram, and we'll do a bucket size of 10. And there we go. Okay, so these are actually the same. What I noticed was, and this is quite an interesting point, is that we didn't start the axis at 0, so we should absolutely go and fix that, because this is extremely misleading at the moment. So let's go ahead and make sure we just fix that, because I was wondering why these two look different. So we'll go to vertical axis and make sure that minimum definitely is set to 0. And now we'll close that, and there we go. So that's actually now, at least now we can compare those. If I just remove that legend for the moment, then at least we have those now, those two histograms looking very similar. They're showing the same distribution. So yeah, very important that you start that at 0 for these column charts, because you're comparing visually. What we're doing is comparing the height of bars. So if we have a cutoff at 40, then we're automatically thinking that this is 10 times bigger than that one, which is totally an incorrect conclusion. So very important that you start these at 0. Okay, so that was the wrong way of generating some data. We looked at the frequency formula. Let's go look at how we do that correctly to create some normally distributed data, which is how we would expect to see exam scores. And then from that, we can do some further analysis with the ranking functions and the sort functions. So again, I have my student data here, my blank student data. Now, obviously, in real life, we'd have the real data, but for now, what we're going to do is say I want to have a mean score. So what's my average? It's going to be 60, and then how spread out is my data going to be? What would I like my data to be spread out? We call that a standard deviation, and it's sort of how near to that mean are we going to be? So we'll give it a 15, so plus or minus 15%. And essentially what we're saying is 2/3 of our data will be in between 45 and 75, so in that, and mostly around 60 in that area there. So it's a plus 15 or minus 15% from the 60, and that's the majority of our two-thirds of our data. So let's go ahead and now create a normally distributed data set. So we'll start with the function norm inverse. So the inverse normal distribution function, that's the one we're going to use to create this. We give it the specified value, which is going to be a random number. And then we tell it what the mean is and what the standard deviation is. So we can use the function rand this time. It gives me a random number between 0 and 1. Then the mean is that there, which is the 60 that we chose, 60%, and then we're going to do a plus or minus, which is our standard deviation of the from that mean. Close the parentheses, we'll hit enter, and then we'll run that down by double clicking, and you can see that's given me now exam scores that are normally distributed, and we'll see that in a moment when we do the histogram. So let's first of all actually just turn these back into whole numbers, because we don't need all these decimal places. We'll just do that by wrapping it with the int function there, the integer function. Now I'll double click, send that down. Okay, I won't do that. I'll just copy and send it down, paste it down, and there I have now a nice set of exam scores. So let's go and highlight this, and we'll do this the quick way this time. We saw the frequency formula already. This time what we'll do is just insert a chart, and we'll go to histogram, and we'll click. We'll just close out. We'll just take it as it is. In fact, we'll just remove the legend there because that just gets in the way, and we'll Command X just so we can go to the top of our page and drop that in here. And now that's looking much, much better in terms of what we'd expect to see from a normal distribution. Let's just tidy up this axis because that's going to drive us mad. Edit chart, customize, and the histogram. We want the bucket size to be 10. There we go, that's a lot better. And so we can see that our exam scores are mainly in this 50 to 60% bucket, and then the 60 to 70% bucket, the majority of our scores, quite a few in the 70 to 80, and then it drops off quite dramatically because we get very few students who really hit these high scores and very few students who hit these very low scores, because, as I said, most students in this test will get the score very close to that mean. So that's now some normally distributed data that we've created. Again, if we keep typing here, if I just type, put a number into here, hit enter, you'll see that all of these scores change because they're all recalculating. This rand is a volatile function, which means every time I make an edit in my spreadsheet, it's going to recalculate and update. So what we want to do is as soon as possible is change these back to values now, because I have the data. I don't need it to keep recalculating, and it would just make my sheet very slow if I leave all 500 formulas there that update every single time I make a change. So we'll highlight them, Command C or Control C, right click, paste special, paste values, back up to the top, and there we go. So that's our nice histogram. We've got some normally distributed data now to work with. So let's go ahead and now look at some other, let's look at the sort function and the rank function. So let's first of all just sort the data. That's a nice easy thing to do. So we'll say sort, here's our range. We'll just highlight A and B, and we want to sort on column 2, and we want to sort true. And let's look at that. So that's put them in scores from lowest to highest. If we do false here, then we'll see them descending from highest to lowest. So let's do descending, because then that does include the heading there. Of course, I could have started from a 2, and that would have then omitted the heading, and I could have just added that myself, but let's leave that there. So that's the sort function. We have a function called sort n. So this time what I'll do is I'll just actually copy the headings, drop them in. Okay, so let's see the top 20 now. We're using a function called sort n. And what we need to do is highlight the range. So we'll grab our range of data here. Let's go back over and back up to the top. Then we want to say how many values do we want back. So we want the top 20. Then how do I want to treat any ties? And if I just click this open, you have various options. We're going to stick with 0, which is just to show the top 20 there. Then we want to pick the sort column, which is number 2 this time. And then is it ascending? No, it's not. So we're going to go false. We'll hit enter. And you can see there, it just matches. That's my top 20 this time. If I just wanted 10, I could just quickly come in and change that to be top 10. So that's quite a nice function. And one more thing I want to show you now is the rank function. So let's say we have this question. So what position in the class was the student who scored 88? So we're going to do rank, and we're going to say what's the value that we're after. So 88. What's the data? And the data is this over here. And then we'll just hit enter this time. And it's telling me the student who scored 88 was 18th position in the class. And if I look all the way down, student 79 was 18th position. So let's take another look at the sort of inverse of that, if you like, which is to say, what score did the 13th placed student get? So we can just count down and work that out, but let's do it with a formula. And we'll say, first of all, we'll sort the data. So sort range is B2 to B501. The sort column is going to be sort column 1 this time, because we're just highlighting the scores, and I want it to be false. So we want to sort them from in descending order like that. So it's just the same as what we had here, but this time I didn't include the students as well. And next what I do is I'm just going to wrap it with an index and just say how far down do I want to go, what row, and I want to go down 13, so to position 13, and just hit enter, and it's telling me that the score of this 13th student was 90. Okay folks, that's what I wanted to show you about. In this lesson I wanted to look at the data with the frequency formula, how we get it to be normally distributed, and then how we can sort it, take the top 10, top 20, and then how we can look at ranking within that data set as well. So thanks for watching folks. Hello folks, we're going to be talking about the subtotal function in this lesson. Now the subtotal function is somewhat of a shy function. You don't see it very often, which is a bit of a shame because it's actually very useful. So here I have a table of 2017 data and a table of 2016 data, and I'm going to show you something very, very simple with the sum. We're going to see a very obvious error, and then we'll go and see how the subtotal can correct that error. And it's obviously a very simplified example, but I really want to get across this point about the subtotal because it's a sort of hidden feature that you may not be aware of. So let me just put in the sum. This should be very easy. We're just going to add up the 2017 data there, and we'll just drop that down there and add up the 2016 data as well, which is simply just a sum of that range of revenue there in that table. Now, if I was to go ahead and do this and do a sum, and I want to get my grand total now for the whole 2017 and 2016 data, I'd then drag that all the way down. If I did that now and hit enter, you'll notice obviously it's immediately apparent that we're double counting. If we're doing the sum, what we'd need to do is in fact just add that and that one together, and really we should see that it's actually the correct answer is that 49 there. We could have also said it's the sum of that and the sum of that there, and given it those two ranges and said, hey, that's my total there. That would have been another way of doing it. So if I use a sum across that whole range there and it has those two previous sums in, it's going to give me the wrong answer by double counting, so that's definitely a mistake. So hopefully none of you will ever make that mistake, because it's pretty easy. But let me just show you what happens if we try that with the subtotal. Exactly the same data set, and the subtotal is written like this. We say subtotal, and then we give it this function code, and we're going to talk more about that in just a moment, but for now just put the number 9 in. That means I want to sum my data, and then we'll do the range there. We'll hit enter, and then I can copy that formula down and just put it into this spot here, and again it just sums that data. So far so good, it's giving me the same answers as earlier. Now this is where it gets interesting. If I do subtotal again down here, we do 9 to make it a sum, and this time I include the entire range data with the two subtotals as well, and then I hit enter. You'll see this time I get no double counting. Even though we've included that entire range, if I double click, you'll see we've included the entire range there. The subtotal actually recognizes other subtotals and just ignores them to make sure we're not double counting. And so the subtotal has a nice property of never double counting if you're using it. So that's just a handy little hint to know. Let's see one of the other great benefits of the subtotal, which is, let's say I have, again, I've got just the 2017 data here this time, and I've put a subtotal in, same as before what we saw. Now what I'll do is I'll just highlight my table there. I'll throw on some filters by just clicking up the filter button up here. And let's say this time I want to look at just the data from the United States. We'll click that, we'll click OK, and it just picks the 5 United States rows of data, and now the subtotal updates nicely and shows me that just those 5 updates the subtotal, so it excludes those hidden rows from my total. Let me just show you what would happen if we'd had the same sum in here, and we'll just add those all up. And if I do that same drop down just to United States, you'll see that the sum doesn't ever change. It still shows me as 28,000, and so that would be then misleading if someone came along and just looked at this and didn't realize there was a filter on. And finally, let's just talk a little bit more about this thing called the function code, which I just mentioned before. So if I just put the subtotal back in, you'll notice that the first argument is this thing called function code, and I look down the codes here. I've just pulled the table. I put the table here from the Google documentation, and number 9 there corresponds to a sum. So if I type 9 here, it's going to apply the sum as my aggregation method. Then we'll put in the range again. We'll close that parentheses, and it gives me the 28,000, which is the sum of all of that as we expected. Now let's say I wanted in fact the average revenue. Then I can just change that 9 to a 1, and it gives me there the average now as 2,000. So again, you can use, if I want the max, then that's going to be number 4. So you can use any of these in your subtotal to get different metrics here in your aggregations. Now that allows you to do quite a nice construction by building a dynamic drop-down menu of these aggregations and then applying that directly in your formula. So let's see that in action. So first step is let's put an aggregation, a drop-down menu here. So we'll come up to data, we'll go to data validation, and we'll do a list from a range, and we'll do that list there, that range, click OK, click save, and now I have all of my different options here. Just quickly, a quick note, if you're unsure what the difference is between these, well, the standard deviation population is when your entire data set is the whole population, The plain standard deviation is when you're expecting to do, you're working with a sample of data, not the entire population. Okay, so we've got some, at the moment nothing changes if I do this, but what we'd like to do is actually now, instead of having the number 4 here, we'll put in a quick dynamic lookup here to just take the choice here, look it up, return the code, and put the code into the formula here. So let's just do that. So again, we'll click where that 4 is. Well, I'll start actually we'll build this up. So let's move this one out of the way. First of all, let's just do a match first. So we'll look for this one, and we're going to match it in here, and we want to match it exactly. And that gives me the position in here. And in fact, that would work perfectly well, because the position here, because I've got them in order, it corresponds to where the code is. But just to be complete, let's actually, just to be really sure, wrap this in an index so that we actually return the value from here based on its position from this match. And that now gives me the code. So if I change from average to sum, we'll see that jump up to 9, which means now I can just put that into my subtotal. And then we want to sum up here, close those parentheses, and that's it. Let's format it as a dollar amount, so we could have the sum there. If we want to change to the average, you see it just updates that figure very quickly. If I wanted to find out the minimum or the maximum. So you can build very nice constructions in your dashboards and your reports by using these subtotals, and quickly change the different measures, the aggregations you're using across the entire dashboard to really very quickly explore and understand your data. So the subtotal, like I said, it's kind of a rare function. We just very underused, I suspect, but it's very useful and really not hard to understand or work with, and it has lots of great features and advantages over doing static aggregations. So it might be worth checking out. All right, that's everything, folks. Thanks for watching. Okay, so welcome to this lesson on getting data out of pivot tables. So here's a data set again of these exam scores, and I've built you a little pivot table which just has the count of how many people from each grade took the test and what their maximum score was. Now, one thing before we get started I'd just like to show you is that the range I've selected is A to C. Just bring that up here, A to C, which means that it's the whole of column A, the whole of column B, and the whole of column C from sheet 1 that I'm using in my pivot table, which means if I add extra data at the bottom of my table there, extra exam scores, they'll show up automatically in my pivot table. So let's close that down, and let's now imagine that this is the calculation I want to do. So I have 500 students in my school, and I want to know how many people have taken this test. So it's a very simple calculation. We are going to take the 129, which is the total of all the counts, so how many have taken the test, and divide it by the total of all my students, which is the 500 there, and just change that to a percentage, and I can see that 25.8% or 26% of my students have taken the test. We can do the same thing for the 5th graders here. So we'll say, let's say how many took the test in the 5th grade. It was 60 of the students, and then divide it by the total number of students in the 5th grade, which is that 87 there. Hit enter and convert this to a percentage as well, and 68.9, so nearly 70% of 5th graders have now taken the test. So that looks great, and I'm pretty happy with that. Why would I need to do anything different? Well, let me show you what happens if I add in a 3rd grader. So let's imagine we have a prodigy in the 3rd grade who also takes the test. Test A, and scores a respectable 56.2. Now then, that will show up in my pivot table. There's my third grader, 56.2, but unfortunately my formula has now broken down here when I was using to calculate the number who've taken the test. And the formula has broken because that grand total has shifted down one row from row 7 to row 8, but our formula is still referencing row 7, which is now the 8th grade row. Similarly, with this 5th grader calculation, I'm no longer using 5th graders in my calculation, I'm using 4th graders, so that one has also changed and broken. So that's no good. And just to make sure you believe me, if I undo, if I go Control Z and take off that 3rd grader, we'll go back, you'll see that we have 25.8 and 68.9. If I refresh, add that guy back, then you can see they go down to 0.8 and 17.24. So they're definitely changing, and they're not now, these are incorrect now. So there's another way we can get hold of the data from our pivot table, which is the robust way of doing things. So let's use this function called get pivot data. So start typing it out, and as you type the word get, you'll see that it comes up as an auto suggest. So let's hit tab and complete it. That brings up the whole function name without me having to type it. And you can see what happens is it wants first of all, it wants the name of the column of your pivot table you're interested in, then a cell reference from your pivot table, so Google Sheets knows which pivot table is yours, and then some optional additional columns and pivot items. But we'll get to those in a moment. They're optional, so we'll leave them as this first example. Now I'm going to just close this down with the X up here so that we can see our pivot table. So the first thing I need is my pivot table column, and it's this one here, count of exam score. So I open my quotations, I type in count of exam score and close quotations, and then I just need to give it this formula now a cell reference from somewhere in my pivot table, and I tend to just pick this first one by default, so the one that's just above the rows and just to the left of the columns there, so that's B1. You can see it's highlighted orange there, and then I can close this bracket here, hit enter, and I have 130 showing up there. And then I can just say divide that now by the 500 and turn that into a percentage, and there we have my percent sign. Now just to show you that this will continue to work even when we add additional rows to this, let's go back to sheet 1 and let's imagine that we actually have a 2nd grader now take this test as well. He takes test A and scores 34.2. Let's take a look at the pivot table, and you can see that it's added the 2nd grader there, but my total is still working. It's still taking the 131 over the 500 to give me 26.2%. So that's the get pivot data, and that's how I use it to make sure my calculation here is robust, because I can see this one here is no longer working. It's pulling out the 50 now, which is obviously not the total number of students that have taken this test. Now we can even take this a step further and actually pull out, for example, this 5th grader number, which was the one we were looking at before. And let's just make sure we can see this calculation and compare it and make it work. So at the moment we had this one from earlier that broke and that didn't work. So let's go ahead and just update that one to be C5, C6 even. And that's the 5th graders there with the original calculation. Let's do it now with this new get pivot data. So I'm going to type get pivot data, and we'll type count of exam score, and it's B1. And then this time I want to give it the name of the original column from sheet 1. So for now, let me just close this out and we'll talk about sheet 1 here. So I want to now tell my get pivot data, I want to say, hey, I want to use the grade column, and I want to use everything that's 5th grade. That's how this one is going to work now. So we'll come back here and modify this. And so I said, first thing I need to do is type in the name of the original column, which was grade, and then what's the pivot table value that I want, and that's this 5th grade here. So 5th grade, and then I hit enter, and that gives me the 60 there. And then I can now do the division to get the final calculation working. So I divide it by the 87, and then I format this as a percentage, and I get my 68.97% as we had before. Now let me show you why this is much more robust. Let's imagine that in fact the 2nd and 3rd graders had taken a totally different test and weren't meant to be in this data set. So let's go and delete them. So I'm going to come back down to the bottom of my scores here and just remove these two. come back to my pivot table, and you can see that the 68.9% is still valid because it's pulling out that 60 over the 87, whereas this one now is totally garbage because it's looking at the 8th grade completion rate. So that's why it's really important to use this get pivot data function, and I've shown you a couple of examples there. We could keep adding more variables here. If I had additional data points, I can add more complex examples in here if I want to get beyond that. And that's how we use the get pivot data, and that's why when you have a pivot table built and you want to use any of those scores or values rather in your calculations, it's important to use this formula here. So that's a look at get pivot data. So thanks very much, folks, and I will see you in the next lesson. Hey folks, let's talk about a function in Google Sheets called hyperlink. Now this should be a nice easy lesson compared to many of the other ones, the more complex functions and formulas that we've been exploring. It's a very simple formula, and we'll start by typing hyperlink, and all it does is put a link into a cell. So you just type hyperlink, then you put the link, the place you want to go. So let's pop my website in there, and then we'll say visit my lovely website, please. And then the second argument here is the text that we'd like to display in the cell. And when I hit enter, you'll see it then just shows that, and it shows it as a hyperlink in blue with the underline. And so if I click that cell, then I have this option here to click, and it will just open that link for me. And there it is, it's opening that link in a new page for me. So that's all it really is. Sometimes I find I want to work the other way. So I've imported or copied and pasted a lot of links into my spreadsheet, and I want to convert them quickly to text. Then there's a nice formula called to text, and I'll just highlight that there, and it will just then convert into text for me very quickly. So that's a nice way of just removing the hyperlinks if you want to. Now I often get asked if there's a way to extract the link that's behind this here, because you can see that the link is the Ben L. Collins website. All we can see in the cell is this visit my lovely website, and unfortunately there's no way a formula can get to that link there behind the text. It can only see the text at the text level, because that's all that's showing on my spreadsheet. So you can't extract that link, unfortunately, from that hyperlinked cell. Now another use for hyperlinks that was introduced relatively recently, I think earlier this year, is the ability to link to other sheets, and specifically actually the new part was to link to cells within a sheet, which is really useful because you can now start to build like content pages, if you like, a table of contents rather, for your larger spreadsheet. So if I want to hyperlink to another sheet within this, or another tab rather, within my spreadsheets, I can say hyperlink, and then I'm going to go and find out what the URL is of the sheet 2. So let's click on sheet 2, and you'll see that there's the URL up there. It's that big thing. So let's copy that, put that into sheet 1, and then let's give it a nice text name, link to sheet 2, and now I have a link, and if I click that now, it takes me to sheet 2. Now the nice thing is I don't actually have to type in that whole long URL if I want. I can just type in, it knows I'm inside of this sheet, so I can actually remove that reference to the sheet and just simply refer to the tab there, which is just that GID portion. So as long as I leave that in there, then it's still going to work, and it's still going to send me to sheet 2. And you'll notice I've created a take me back to sheet 1 already. Now sheet 1 is always a GID 0 in all of your spreadsheets. So that's a nice easy one if you want to get back to your sheet 1, your very first sheet in the order here. Now I can actually link to a specific cell as well even. So all we're going to do this time is let's copy this formula exactly as it was down here. So that links me to sheet 2 with that GID, and then what I do is just add in and range equals, and then I give it whatever cell reference or range I want to go to. So this time it's C41. Let's see what's at that cell, and we'll change it to cell C41. Let's go and see what I've put there. So now this time it'll link to a very specific cell. So we'll click that, and there it takes me to C41. It puts that at the top of my, put that at the top corner. It sort of went straight there, and I've put the little word hello. So hello, then we can go back to sheet 1 if we want. Okay, so what about hyperlinking to a range? That's exactly the same. That's totally possible. So we'll copy this again. And then this time, let's go and find sheet 3. I've put this nice little range in from F79 down to F87. So let's copy the GID for this sheet. Let's go all the way back up to A1 so that we don't know where the range is yet. And we're going to just now change this here to say, so we'll swap out the GID. And then we're going to say, in this time, and range equals, we said F79 colon to F87, and it's going to be linked to sheet 3. Oops, and it's the range F79 to F87. So now if we click that, and we click that, then it's going to take me straight to that range and highlight the range for me, and put it also up in the top left corner of my sheet for me. Now, let me just show you one other thing that might happen is if I hide this column, and then we go back and let's try our link again, let's see what happens. Then this time it's going to tell me it cannot open the link because that range is hidden. Would you like to unhide it? So it copes pretty well with the hidden. If you're quick enough, you have to be quick to find it. So let's unhide, otherwise that little message disappears, and then you can open that column very nicely. So that's how it deals with hidden sheets. Now, so far we've been linking either to an HTTPS, or you could easily do an HTTP for some of the old websites that don't have the secure links yet. We've also seen internal linking here with just the # and the GID reference to get to one of my sheets. You can also, there are a number of other links, a number of other link types that you're allowed. And so, there's a link below this website to the Google documentation reference, so you can check out what that list is. But perhaps the most useful, the one you might be interested in, is we can put a link to be able to send an email directly if we wanted. So maybe if you are sharing a template and you wanted a help button, if you like, you could say, hey, this is a button to just mail, send a direct mail with some feedback or a question. So we could say, this time, rather than the HTTPS, we can say mail to : ben@benlcollins.com, and then we'll say send, the text will say send an email to Ben. Now, if you go to click on that one, it will open up your editor, and it will then open up a brand new, fresh email, and it will have Ben@benlcollins in the 2 lines, so it's ready to go. And so that's a nice little quick way of just adding that feature if you want it. There's that new message ready to go. It's using mail in this instance, but it's going to go to Ben Collins, and we could send a test email from spreadsheet hyperlink, and we'll just fire that one off. So it does end up opening this tab for you, so you just get rid of that one. So that's the mail to there, that one there. That's quite useful, a nice little link type that you might use. One last thing to show you is we could also, let me copy this one down here. We don't have to have any text. I can leave this and perfectly I'm allowed, if you like, to just leave a blank cell there, and it still has that link. It'll still take me to sheet 2. Let's go back to sheet 1. So I don't have to have anything in there necessarily. So just a quick, wanted to just note that might be something useful to you. And then final thing I want to just mention with the hyperlinks, that's a question that's come up before, is it possible to have text, the hyperlink just showing as part of a cell? And the answer is no, unfortunately it has to be the whole cell. And I'll just show you that in action. And if I hit enter, then it's there and the text is there correctly, but the hyperlink just doesn't come through. It's unfortunately not part of the cell there. So unfortunately, that's the way it is with hyperlinks. So you'd have to separate this. You'd have to just cut this and put that into the next cell along with the equal sign, obviously. And then we'd be able to say, there's my link to my website. That's it with the hyperlink. That was a much easier lesson, hopefully, than a lot of the other ones. So thanks very much for watching, folks. So this is the final video in this course about advanced formulas, and I want to just wrap up by bringing together all the odds and sods, the weird little things you'll see if you explore these formulas in details. The first thing I want to talk about is this thing called big num. It sounds scary. It just stands for big number, and it represents the largest allowed positive number in your Google Sheet. But before I show you what that is and why we might need it, let me just explain quickly the scientific notation that we have in spreadsheets. And what I mean by that is when the numbers start to get really large, we stop writing them out as numbers with all of their full digits, and instead we abbreviate them as something times an exponential exponent. So let's see this one here. So I have this number here that's very close to 1, and if I multiply that by let's just multiply it by 1,000, you'll see what happens. You can see in this little box what it's going to do. If I keep multiplying it, you'll see that we get a very large number. It keeps getting larger and larger and larger, and there you see it flipped from 15. It showed all 15 digits, which is the limit for Google Sheets, and then once I hit that 16th one, it abbreviated it to this scientific notation 1e plus 16. So and if I can keep going and make my number as big as I like, up to a limit of 308. So basically the big number just represents the biggest positive number you can have in your Google Sheet, and it gets written like this. And if you ever frequent the Excel forums, let me just take up a few of these. Let's see if we can make this look. There we go. If you ever frequent the Excel forums, the big num will look more like this. It will be something like 9.909 e plus 307. And oops, let's just shorten it down to make sure we can see. That's what the biggest number is in Excel. That's what it would look like. And in Google Sheets, we can actually write it. We can actually represent it, the big num, like this. So a 1 plus 308 zeros effectively after it. And so, first of all, why am I telling this? Well, I'm telling this because it's something probably that you won't ever use or might never use, but you might see it in a formula. If you go to the Excel forums and you're looking through the advanced formulas, every now and again you'll see this pop up. And so if I can explain it now, it's at least then you'll know what you're looking at. It does have a use case in with a lookup or a match when you're trying to find the largest value, or the last value rather, in an array. Then you can use this big num to make sure you get to the very end, because nothing else can be bigger than it. So for example, if we look at this array here, let's just clear that one up. If I look at this array here, then you know, I have a bunch of numbers, and if I want to find the very last one, I mean, this is a totally an easy example. Obviously, we could use other ways of doing this, but if I use the match function and I search for the big num, so we'll do 1e plus 308. So we'll search for the biggest number there is in Google Sheets, and we'll search for it in this this range here. And rather than put a 0, which would be an exact match, because obviously we're not going to find it, we'll put a 1, or if we like, even better, we can just leave it out because it's 1 by default. We'll hit enter, and it tells me on the 10th row is where I find that largest number. So what's really happening here is that the match function uses something called a binary search algorithm to find the largest value that is less than or equal to the search value. Now, we've given the search value as the biggest number in Google Sheets, and in this mode where we've specified an approximate match, then the match function is going to assume the numbers are in descending order. And so when the biggest number, which is obviously not going to be found, isn't there, it's going to give me the very last position of the array of numbers in that range there. So essentially it's saying I'll find the biggest, I'll look for the biggest, but I won't find it there, and I will just give you back the last number in the range. If I want to extract that value there at the 10th row very quickly, we can just do that with the index function. We've seen that already, and it's very, very simple. So that gives me back the 98. Okay, so that's big num. Let's take a look at the next little tidbit for you, and that's this function called u+, which is an old unary operator, it's called, and it just acts, it's a function that acts on an array. So we have this filter function. So I typed a filter function, it just exists in that first cell, but it gives me an array output, which is all of those values above 900 in my dataset here. Now if I want that very first one, let's copy this across to here. If I want that very first one, I can use this function called u+, and it just simply pulls out that very first value for me of that data set. These aren't necessarily in order, by the way, that's just the very first one of the array. I can also achieve that same result by just putting a plus in front of my filter there, and that does the same thing. That's the same, it's a plus, it's a unary operator. Another construction you might see, especially if you're looking around in some of the older Excel forums, is a double dash, a double minus sign in front of formulas, and again that can be pretty confusing or look pretty weird at first. Let's say I wanted to know how many, which of these were blank with an array formula. Then I might do something like equals is blank, column A, and then hit the array formula, and it gives me some falses and trues. So if I now multiply these by -1, and you'll see what happens is it turns the blanks into, the falses into zeros and the trues into -1s. So if I multiply them by a -1 again, then we now get them turned into zeros and ones. So it coerces the trues and falses into zeros and ones. So if I just copy this, let's just lock that first, and then let's copy this over here, and this time I'll put a double dash in front of that is blank there. Then instead of the trues and falses, I get zeros and ones, and that's obviously a lot more useful because I can now do math on these zeros and ones. There's one other way you can do this with the n formula. So if I just have the is blank, so I start with this one again, gives me the trues and falses. This time if I put an n in front of that, then it turns it into zeros and ones. And that one is the little formula called n. And what this one does is it converts falses into zeros and trues into ones. So again, achieves the same effect as the double dash, and it's a nice little way of coercing falses and trues into zeros and ones for calculations. So that n formula can also be used to add comments to your formulas. So if I have a very simple formula here that just simply adds the numbers up, but I wanted to make a note of what that formula did for my colleagues or for the future, I could add an n here over the brackets and then type some text. So I could say this formula adds up all the numbers above. And it won't change the result, because if I look at n with some text, then what it does is just gives me a 0 answer. So effectively all I've done is said take the sum and add 0 to it with that n and all the text. So you can only put this formula in places where adding a 0 makes sense. So if this didn't give me a value answer, if this had an array output or a text output, then this comment wouldn't be applicable there, wouldn't be able to be added there. But it's quite useful for some big formulas, for example, say on this one here, where I have a formula that gives me a weighted average, and I want to just make a note of this is the formula that gives me the weighted average of a single family home. So, you know, I've added that comment there, and it's just a 0 that just gets added to the result. So that's quite a nice little notation. And since I've opened this one up, you'll just notice there's that double dash I was talking about. So again, good to see that we've covered that, and there's a real use case of it. And don't worry, this formula here, the sum product, is something we did cover in one of the other lessons. So go and check that one out if it's new to you. Okay, last thing to show you for a bit of fun is this formula called char. And what it does is it converts a number into a character according to the Unicode table. So nothing will show for 1 there, but if I double click and I'll send that down, you can see that all of these numbers, they start to have they convert these numbers rather into the Unicode characters. So, you know, for example, if you want a copyright symbol, you can get that one to put into your work. If you want the fraction formulas or an upside down question mark. So you can go ahead and get all sorts of funny characters or special characters you need for your sheets as well. One last thing I'll show you is that you can these formulas go into the tens of thousands. So if I'd kept this number list going, for example, I've just pulled out some of the more interesting ones here. So char 9728, for example, gives me the sun. If I double click down there, you know, some of the modern ones, I got the radioactive symbol, that's kind of fun. Swords, lightning, aeroplanes, stars, mountains. So you can go ahead and draw, you know, picture books if you want in your Google Sheets. And I think that's a good note to finish on. And that's the end of this lesson. So thanks for watching, folks.